Hello to everybody at YouTube. My name is Joey. I'm the CEO of Microraptor Games. You might have seen our development streams before. If not, this is going to be something a little bit different. I've had many requests from people, both on our Twitch channel and on a couple on YouTube as well, for blueprint tutorials. You know, how do you get started in Unreal? So this is what I'm going to be making today. And this is going to be a tutorial for those who are, let's say, a little bit familiar with the interface of Unreal, how to move around, how to start up the engine, you know, open up the blueprint system, things like that. And as we go through it, we'll be starting with the basics of blueprint communication, you know, how do we set up some of the basics for our game here, and I'll be telling you a bit about what we're actually trying to make. So let's start with that. The tutorial focuses are going to be on the topics that you see on the screen up here. I think it's in this direction: blueprint communication, game instances and runtime data storage, blueprint function library, data structures and tables, material instances and parameters, and of course the UMG. We're going to be making a very simple game here, and it's going to be running around, picking up coins. Those coins have value, a score, and once you reach a certain score, the game will, you know, end with a win state, and then you can reset the game or you can exit the game from there. Very simple. How you doing, Neely? And now if anybody during this has questions, or if you're watching on YouTube and you have questions, please go ahead and ask them live, or if you're on YouTube, put them in the comments. And if you want to see something else done to this tutorial once we're finished, maybe like a new feature added on, or, you know, something reshown in a different way, let me know. Making those videos will be very easy. So if there's anything that we can add on to this over time to teach people something else, just let me know and we'll do it. Like I said, so this tutorial does assume that you know the basics of at least installing Unreal, launching Unreal Engine 5, and for note, we are on 5.5.3 at the time of recording this. Once you start up Unreal, you will be met with this screen where you can choose what kind of content you're making. We're going to be choosing game, first person, and we want to do a couple of modifications to the the project default here. We're going to be choosing quality preset scalable. That's it. You can include starter content. This does include some basic meshes and materials to play around with. Like it says, you can add this starter content to your project later, but for our use case, we're not going to need it. Let's just name this project tutorial project. And we'll create it and let the shaders compile as this gets made. Which hopefully will not take too long. If you're on YouTube though, skip like, I don't know, 5 minutes. I don't think it'll take that long though. And in the meantime, I can say hello to my Twitch chat. Hello guys, how you doing today? Happy Monday. Like I mentioned before, if you have any questions during this, or any you want to see something done or explain it a different way, let me know and we can do that. I don't mind changing the general premise of this tutorial a bit if you want to see, you know, some new functionality added in real time. Apart from that though, you know, let's put it this way, I don't mind if this takes all day, but I would like it to be at most 2 to 3 hours in length. So I think we'll be able to meet that goal pretty easily. Now, of course, as you launch Unreal for the first time, in any case, you probably will have to generate these shaders. Once you relaunch the project a second time, you likely won't have to do this. It's just going to have to, it's just to make the environment more streamlined. As you bring in new content, maybe from like an asset pack or something from Fab, you will have to have those shaders compiled in real time. And then when you build the game, you will have to compile shaders for each quality level. We're not going to be building our game here, and we're not going to be bringing anything from asset packs. And likely, if you're working on a fresh game of yourself, you're probably only going to be using 1 or 2 asset packs at most, just to play around with. And in that case, again, the shader compilation just has to happen once, so that it caches those shaders, and then it can retrieve them at any time that you need them. but the first launching of any new project is always the most snooze fest part of it. I was going to do this process before I started this tutorial, but I did want to show exactly which template I'm starting with and how to get to it. I thought that would be an important aspect to this. Of course, you can make this tutorial, this project that we're going to make in any template. I would say you can do it in the third person template, the top down template. I just choose the first person because it is very easy to see what we're going to be doing in real time. But as long as you have a basic movement system, you can also make this in, you know, like the 2D. There are some 2D platformer templates that you can buy or find, and those will you can also make this in there. And of course, there are probably multiple ways that we can achieve the things that we're going to be doing today. They may not be the most efficient, but they will be probably the most accessible, and a good balance between what is correct and what is fast to accomplish and easy to accomplish. So this is definitely aimed at beginners to intermediate users of Unreal and of game development. And anything beyond that, I think, comes with experience and refinement. But for the most case, what we're going to be showing today will be perfectly viable for any game of small to medium size, especially for indie developers. Okay, finally we can jump in, get started. And let me know too, if you're in Twitch chat, let me know if the music is too loud. So when you start up Unreal, everybody should be looking at the same thing that we have here. Again, this does assume that you know the basics of the interface, you know what your content browser looks like. If you're working in Unreal 5, the content browser may not be open by default. You might have to come to the bottom left here and click on Content Drawer, and you can then pin it, I think, with a button in Dock and Layout. And that way you get the content browser stuck down here, if that's what you prefer. I prefer it because it's, you know, from Unreal Engine 4 days. I like having it always visible. But if yours is not visible there, don't worry, it's not going to change the way that this tutorial is done. This is just how I prefer it. So if you click play, right from the start, you will see that we are directly in Unreal. We can pick up this gun, we can shoot it. I'm not going to click the left mouse button because I think it's very loud by default, and it scares me every time that I click it. But we can run around with WASD, we can jump around, and again, this is the basic first-person template. And this is more than enough for what we're trying to do. Now, we can keep the gun there, we can delete it, we can move it around. I'm just going to move it kind of out of the way because we don't need it for what we're doing. And we'll get started with the very, very basics of what we need to set up. In content, I'm going to make a new folder. So right click, and up here we can see new folder, and I'm just going to call this tutorial. This way I can put all of the content that we make into our own correctly named and organized folder setup. You don't have to do this, but I would recommend doing it and getting used to storing all of your game content in organized folders, because as your game gets more and more complex, you're really going to prefer having to do this. And we'll start with the very basics. So we know that our game is going to have running around, collecting coins, and when we reach a certain score, we win the game, right? And some kind of pop-up will make itself visible, and we can choose to reset, or we can choose to exit the game. Very basic stuff. But I know, too, that we need to be able to store this information somewhere. What score does the player have? Now, there are a lot of tutorials out there that will recommend just storing it in the player blueprint for now, right? The first-person player blueprint. It's doable. I think that it works. And if you do it that way, you're not wrong. But there's one key component to that I would recommend thinking about, is that the player's score, the player character, is reset every time you transition from one level to another. So in some cases we want this, right? If we restart the level, the first person character is destroyed and recreated. Therefore, the score is set back to the default value. So that's an okay usage. But if we wanted to have different levels that the player transitions between, when they click on a new level, they enter a door or a cave and they get transitioned to that, we don't want that score to reset. And in that case, it would reset. So one thing that we can leverage to get around that is the game instance. And the game instance is created when the game itself is started, and it's always present. And when you transition levels, the data in that game instance does not change. So game instance up here, and then you might have level 1, level 2, level 3, but this is unchanged unless we want to change it, and not reset. And it's only, destroyed when we close the game. So we want to make a game instance where we can store the player's score and any other data that we might want to store. This is also a great place to store inventory, some networking info, any other player data. We use it in our own game to store just any other global variables that we might need to keep track of. For instance, maybe there's certain choices in the game that the player has made, and again, that might change. Or those choices we don't want to have to reset when the player transitions between level. We want those to remain always present, and even in some cases maybe save those to data, but we're not going to worry about save games right now. But we still want to save this information somewhere where it is always present and does not get reset. And a game instance is perfect for that. So let's make a new folder, and we're going to call this core. I like to call it that because that's where we put the core information of the game. Hey Buster D, we're doing a blueprint tutorial today. Now we're going to right click again, and we're going to make a blueprint class. Now you won't see it here when you see the common classes that you have. Now most of the time when you create things in the game, you're probably going to be creating actors, things that you can put into the level and see. We're going to click on all classes, and this is every single class within default Unreal. Don't get too concerned about this. This is just for more like advanced use cases, and one of these cases that we're going to be using is the game instance. So, loading this on YouTube? Yes, this will all be on YouTube. We're going to type in game instance into the search bar here, and we want to click on the game instance one, not platform game instance, but game instance. Select, and we have our game instance. Let's name this to tutorial game instance. We will Control S to save that. Now, we actually don't want to put anything in here right now. We just need to have it. But right now, if we press play on the game, the current game instance is not set to tutorial game instance. So the way that we do that is we go up to Edit, Project Settings, and this is all of our settings for the game. Now, to make it easier, because I don't even know where we find this, probably somewhere in... It's somewhere. Let's just type in game instance and to see where it's actually located. Project Maps and Modes. This is the one we want. So we can either set it here, or let's go down to Project Maps and Modes right near the start, and we can see that the default game instance class is a game instance. We're going to change that to tutorial game instance. And now if we press play, nothing has changed. But in the back end, the tutorial game instance that we created is being used. And so this means if we have any data that's stored in there, or we want to store data in there, we know that it's being loaded. Let's do that. Let's make our score variable in our game instance. Now we can't do anything with this yet, but creating it will enable us to utilize it further on as we develop the game. You might see this when you double click on it. Just press open full blueprint editor. Some classes of objects do have this like default view that gets loaded, But in most cases, you can view the full blueprint editor to get kind of the standard layout that you would expect with blueprints. So, of course, we don't want to put anything in the event graph, right? We don't want anything to happen, no events to occur when the player loads this tutorial game instance, at least for now. All we want to do is store the player's score. Now, if you're not familiar with any variables, if you go over to the left-hand panel here, you can see that there are graphs, functions, macros, variables, event dispatchers. The player's score is going to be a variable, right? It needs to be 1, 2, 3, 4, any of these whole numbers. Now, unfortunately, a whole number in mathematical terms is not a variable in programming terms. But what we're looking for is called an integer, right? No decimal places, just whole integers, and in our case, we're going to be relying on them for the positive aspect of that integer. So we're going to click on variable, and we're just going to type in score and press enter. And we can see here that the variable type is Boolean, true or false. The player's score is not measured in a true or false, case. We want the integer, so we can click on this button, or we can also click it on the right-hand details panel over here to change it to integer. If you wanted your score to have decimal places, you would want to click float. But we just want integer, and we want a 32-bit integer, not 64-bit. 64-bit would allow for a greater range of numbers, but in our case, I don't think we want the player to have more than, the integer limit of score, somewhere, like 2.1 million, right? I think billion, sorry, 2.1 billion. This is fine. A regular integer is a-okay. So let's press compile to compile this blueprint. And we can see here that the score's default value is 0. That's fine. The player will start with 0 score, and of course that score is going to be added on to as you play the game and as you collect these coins. Nothing else right now is relevant to us. We've created our score. It is there in the game. We cannot see it. But when we now press play, there is this variable being loaded into memory of the score, and it is currently set to 0. Now, we can even test this. Let's go to the event graph, and we will... I don't think we can tick this, but we can do begin play. If I'm not... No, we cannot. So let's do this in a slightly different way. We're going to open our level blueprint. So when we press play on the level itself has functionality that we can add to it in the form of the level blueprint. And we can get to this by clicking up here, right next to these symbols here for quickly adding something to the project, or display a list of level sequence. We're not going to be doing any of those, but we do want the level blueprint itself. Click on this, go to level blueprints, and open the level blueprint. And in here, you'll see that they're very similar setup here. We have the detail panel, we can create variables, we have an event graph. In this case, the level blueprint is a great way to run things usually at the start of the level. So when the level is loaded, when the player loads into it, what do we want to run? And in some cases, you may want to run some quick variable sets. You may want to tell an actor to start, moving, or, run a quest start when the player loads into the level, whatever. This is a great place to do it. And we're going to be just doing that to test our score integer and see what it is and whether or not it's working. So let's right click into this. And we have a whole bunch of options to create blueprints into this. And we can see anywhere we might be able to click on something and we can create a blueprint for that. This can be very, very intimidating to new users, but for the most part, just know that it is context sensitive. So generally speaking, you want to keep this Boolean ticked. And in most cases, when you are creating things or dragging off from nodes, you're going to be met with a list of options that make sense for what you're planning to do. If you have a Boolean, a true or false, and you drag from that, the only things that it's going to show you are things with Boolean inputs or where that might be relevant. So what we want to do is we want to call an event when the player begins the map. This is called begin play. And if you start typing in begin, you'll see that it does default to begin play. This is, something that it considers to be, when you type in begin, this is likely what you want to do. Event begin play is run whenever the player starts this level, as mentioned. And if we drag off from this execution node to say, okay, when event begin play fires, what do we want to run? We're just going to run a print string, right? A debug print. And it's going to print the text hello. We can test this by pressing play and seeing that hello is in the upper left-hand corner of the screen when we press play. Sorry, I had to ban someone. You can change some of the default information here, so you can double click and you can change the string to this is a tutorial or something. And when you press play, this is a tutorial. You can change the duration and the text color, so maybe you want to do that for various things. Maybe your errors you want to be red, and for things that are successful you want them to be green, right? To test if it's working or not. Instead, we want to find a way to grab our game instance and grab the score number and display that on the screen so that we can see, okay, is this actually loaded into the game or not? So we're going to right click and we need to grab the game instance. Now, thankfully, Unreal has a default node for this called get game instance right here. And as you can see, returns the game instance object. Now, if you'll know, our tutorial game instance is the name of the asset. That is the unique identifier of our object here. And if we hover over the return value, it says game instance object reference. Technically speaking, our tutorial game instance is a game instance, but the engine doesn't know which type of game instance it is. Because if we go back to our project settings, maps and modes, we can see that there are 3 game instances actually in the project right now. 2 of them are default to Unreal. 1 of them is the one that we made ourselves. So when it's saying, okay, retrieve the game instance, we actually are not retrieving our specific game instance, or in this case, it is, but the engine doesn't know that that's what we're trying to call. It's a little bit confusing, but generally we want the actual output to match the object that we've created here. So in our case, we want this to be grabbing the tutorial game instance. How can we do that? We can drag off from this and we can ask it to treat this game instance object as the tutorial game instance and retrieve information that would be within that specific blueprint type. And we're going to be using a cast node to that. Cast to tutorial game instance. Now let's hover over this and we can see exactly what this does. It tries to access the object as a blueprint class, tutorial game instance. It may be an instance of. That's exactly what we want here, right? Now, it does say note that this will cause the blueprint to always be loaded, which can be expensive. In our case, the tutorial game instance is always loaded, right? Because it's always present in the game. So this is not adding any additional overhead to our project by including, and in most use cases, it is okay to use cast nodes. But you do want to be careful that a longer chain of cast nodes may result in a game that has a very large memory blueprint to it. In this case, though, for this tutorial, we aren't going to worry about that. This is going to be just teaching the basics. And if you're retrieving your game instance, it's okay, because in this case, it is always loaded anyway. This doesn't really have anything additional to it. Now, if we hover over this as tutorial game instance, we can see that the new reference is not game instance object reference, but rather tutorial game instance object reference. If we tried to drag off of this and grab our score, we see nothing. If we try to drag off of this one and we type score, we can now see our score. We can get and we can set. And that is the basics of manipulating data in any game, getting that data and setting that data, right? In this case, we want to grab our score. And we can do that. We can see the connections between these. Now, the white nodes here, the execution nodes, or exec, are the ones that actually fire events. So when we event begin play, we cast to tutorial game instance this object, and it searches back for the game instance. It treats it as a tutorial game instance in this case. So we say, okay, grab the game instance and then treat it as a tutorial game instance object. And now the engine knows, okay, well, as tutorial game instance object, we have the score variable within there. And we've grabbed that score integer. And now what we could do is, if this cast succeeds, which is this top execution node, we can print a string. If the cast fails, that means that the game instance is not the correct game instance, right? And we could even test that by changing our game instance back to game instance. We can drag another execution for print string and type game instance is not tutorial game instance. And we'll see whether or not it prints hello or game instance is not tutorial game instance. As we can see here, game instance is not tutorial game instance. It showed because the cast failed. It grabbed the game instance and it said, are you tutorial game instance? No. Then we will execute down to here. If we switch that back and we press play again, we see hello because that succeeded. So let's just keep that there because why not have a little bit of debug? And as the print string, we wanted to print the score. How can we do that? Well, very simply, we can translate, we can convert the integer to a string, right? Because if you type in on a text document a few numbers like 1, 2, 3, 4, 5, I think you do Durev Arushka for the follow. Thank you for that. We type in 1, 2, 3, 4, 5 on Notepad. This is not an integer, right? This is a string. It is text, but it is alphanumerical text. So we can very easily convert a integer to a string, and Unreal thankfully does that for us. Converts an integer value to a string. So if we press play, now we see 0, because that is our score. Let's jump back over to the tutorial game instance and let's change the default value of score to something random, right? 1, 2, 3. If we press play now, we can see that our score is 1, 2, 3. So we are correctly grabbing the player's score. And we can see that this is in fact functioning. Let's change this back to 0 though, because that's what we want the player to start with. So we know we have our score. We have it displaying. We don't need to display it any longer. So we will just disconnect this functionality for now. So the nodes still exist. We can connect them at any time that we want, but for the sake of the tutorial, we don't need to display the player's score at the start of the game. There's no really use case for that. Let's jump back to our content browser, go back to our tutorial folder. Let's make a new folder called Blueprints. Let's jump into it. And let us right click, Blueprint class, and we're going to make, in this case, an actor. An actor is an object that can be placed or spawned in the world. Our coins that we want to pick up will be spawned in the world. We will place them ourselves, and the player will then be able to run into them and get score. But in that case, we need to actually make the coin, right? So let's make a new actor, and let's call this BP underscore, BP for blueprint, coin. Let's double click on this. Now, this is a little bit different than opening up the game instance where we have this event graph, or the level blueprint where we have the event graph. Now we see this viewport where we can place objects. We can, make it however we want. And when we place the coins in the world, we are placing an instance of this coin, right? So we are creating the base object that the copies or instances of will be based on. Now we can, of course, always switch to the event graph, and we can see that this looks very similar to what we have in the game instance and the level blueprint. And in this case, this is where we handle the functionality for the coin itself, right? So let's jump back over to viewport, and we're going to go up to components, and we're going to click add. Again, there's a big list of things that we can add here. We can, add in lights, we can add in different physics things, audio aspects, different splines, collision, whatever. We just want to start by adding in a cylinder. So let's type in cylinder. And when we click it, we can see that the cylinder is added to the viewport. What does that look like though? When we see the blueprints folder now, we can see that BP coin has a default image of our cylinder here. Let's drag this out into the map. And you can see that our cylinder is present within the map. This is our BP coin. If you look in our outliner, which is the list of objects in our scene, we can see BP_coin is within the scene. And we can even see that the type is BP coin, which is our blueprint class. And if we click play, we can see our coin in here. This does not look very much like a coin right now, but we do have a cylinder and it has its own collision and everything. And this is an instance of BP_coin. This is not BP_coin itself, and we're going to be delving into what that means very soon here. But what we kind of just need to consider it as is a copy, a form of BP coin that we can change and we can add on to in any way that we want. We could even add on something within this specific instance over in the details panel. We could add maybe a sphere to it, and we could move this sphere around. But if we click and drag BP coin into the scene again, we can see, well, this version, this instance of the coin does not have that sphere attached, but this one does. So generally speaking, if we were to change now the cylinder to maybe, let's say, a cube, or to delete the cylinder itself, and we come back to the map, we can see that there are still two instances of BP coin in the scene. One of them still again has that sphere, the other one does not, right? So we can add on to the default values of that coin by editing the instances. Let's delete these both for now though. Let's add that cylinder back. And let's make this look more like a coin. What I'm doing is changing the scale of this object. Now, if you're wondering how I got to that, you can either click these up here to select, to change the transform, to change the rotation, or to change the scale of objects. You can also type in W, E, and R on the keyboard for shortcuts to accessing these. So I pressed R, and therefore I can adjust the scale. If you want to get rid of the jumping, right? The what's the term for it? The if you want to make it so you can scale more smoothly, you can go up here and you can click these buttons up here to turn off the snapping. Sorry, that's the word I was looking for, of these different elements. So in this case, we can turn off all of these snapping, and now we can more smoothly scale it down to look like a coin. Now, if we put this in the scene now, we can see that this is definitely looking more coin-ish, but it is still pretty big. So let's adjust it on the X and Y scale. And a little bit more here. And we can see that that is definitely smaller and more coin-like in size, but still big enough that the player could see it from a distance. Next, let's rotate it so that it is kind of facing in the direction that the player would expect when they see a coin in the distance. In this case, I'm going to turn back on snapping for rotation so that we don't have to try and figure out 90 degrees by scaling it in the viewport. We can also come over and we can type this in, and we can see that that works as well as an option into the transform of the cylinder mesh. Either one works. So now if we look in the scene, we can see that we do indeed have a coin, and we can place a whole bunch of these into the scene, like so. Make it spin. We can make it spin. We can make it spin. Let's worry about that a little bit at the end after we have the base functionality. Then we can start adding in some quality of life and some fun stuff to it. But we can make it spin. You'll see a few problems with this. Number one, when we drag them into the scene, they are by default placed into the ground. That's kind of annoying, right? And that's because the root of the blueprint itself is right in the center of the screen. Right where you would see the grid coming together. We can fix that by dragging the cylinder up off the ground. And now we can see when we place these in the scene, or when they are placed in the scene, they are by default hovering above the ground. This makes it a lot easier for us to kind of work with, right? And if we could click play, we can see that these cylinders are in the game are coins, and they're hovering at a pretty good height for us to interact with when we want to run into them and collect our score. By default, I'm going to rotate these as well in this direction, 90 degrees. We're going to compile that, and that way when we place them in our demo level here, they will be facing the correct direction. Of course, you can always modify these instances in the map by rotating them yourself, because these are, you know, like children, or in this case, the proper term is instances of that base. So let's delete these, and we will just start with 3 of these. Now, one thing you can do is you can right click and you can duplicate these objects. Edit, duplicate, or you can see Control D will also duplicate these within the scene. So we can duplicate and then move that duplicate over. We can Control D and we can move it over. Or my personal favorite is to hold Shift while the transform gizmo is active and drag off. Oops, sorry, not Shift, Control. Sorry, again, it is Alt. It is Alt, sorry, I forgot that. It is Alt, and that creates the duplicate as well. So right now I'm holding Alt, and every time I click and drag, it creates a new instance of that. Be good if I can remember the actual keybinds here. So it is Alt, just to get that clear. So now we have 3 coins out in the scene, and right now when the player runs into them, nothing happens, right? They're pretty static. In which case, that is the kind of point of a static mesh. It is unmoving. It doesn't do anything. We have no functionality hooked up to this. They're just existing. So let's start by making them actually disappear when the player runs into them. Now, there's a few ways that we can do this, but I think one of the simplest ways is to make a collision box that when the player hits it, the coin disappears. So let's come up to the components and let's add in, type a box, and we can see box collision. A box generally used for simple collision. Bounds are rendered as lines in the editor. So when we click this, we can see that the boundaries of this box, as it says, are rendered as lines in the editor. And we can see these in the editor. We have this box collision. Let's drag this up to be within the boundaries of the box. And you know what? I'm going to make it a child of this cylinder too. In this case, we can do that by clicking and dragging box and drop here to attach box to cylinder. So that when the cylinder is moved, the box gets moved with it. This will be important later if we want to have the coin spin, or we want the coin to move up and down, or, you know, across a larger distance of the level. Now the box will be attached to the cylinder, so all we need to do is move the coin. And let's, you know, for the sake of it, let's rename cylinder to coin mesh and box to coin collision. That way, when we are referencing them later for logic, we know what they're named and it makes a bit more sense, rather than just referencing box or cylinder, right? So now if we take a look at the map, we can see that by default, the box collider is roughly around the location of the coin mesh itself. And now if the player presses play, they won't actually see these lines in the editor, right? Because no player wants to see the collision for a coin or for a trigger, for maybe like a quest trigger. If you've ever been playing a game and you see enemies spawn when you reach a certain area, right? That's probably a collider of some sort that is determining, okay, has the player entered this collision box? Now run certain logic. We're going to be using the exact same methodology to destroy our coin and to provide the player with score. But when the player presses play, we don't want them to see where this collision actually is. Now, you can also see that when we press play, still nothing happens. In fact, we don't even see the collider, and it doesn't seem to be working in the way that we would want it to. This is because by default, the collision for a collider like this ignores the player. It overlaps the player, and it waits for certain logic to be called. We don't have any logic hooked up. But we can come down to the coin collision and we can see its own collision setup. So in the details panel with coin collision hovered, we can expand the collision presets section, and we can see that it is set to overlap all dynamic. The player is dynamic, right? The player is not a static being. In fact, the player is considered a pawn, and we can see that it is set to overlap the player. And now above the collision presets, we can see that it is set to generate overlap events. This is very, very, very important. So when overlaps happen, it is set to find some event and to play logic when an overlap occurs, and then we can do certain testing. We can run, you know, the score update on that logic. That's the intention. And we do want to, in that case, to overlap the pawn, not ignore it, so that when an overlap occurs with a pawn, like the player, we can do that test that we needed to do. So how do we call these events? Well, let's go to the event graph. Similarly to in our map, we have event begin play. We can now call events that are related to this box collision. Where do we find that? We can either scroll all the way down on the coin collision, and we can see a bunch of events that can be added to our event graph for various different things. On component hit, on component begin overlap, on component wake, begin cursor over clicked released. A lot of these are not relevant to our specific use cases, especially because the player is not going to be clicking on them. The player is not going to be mousing over this box. They're going to be overlapping with this box. So let's click on component begin overlap. Event called when something starts to overlap this component. For example, a player walking into a trigger. Well, that's exactly what we want. So let's click add, and we can see that this event has now been added to our event graph. Let's try something very familiar to us. Let's drag off the execution and type print string. And that's it. Now let's click play, and when the player runs into these coins, we can see that hello is being printed onto the screen every time the player is overlapping with one of these boxes. And for the sake of debugging, we can actually make these debug lines that are visible in the viewport visible in-game by looking for the rendering hidden in-game. We're going to set this to false. By default, it is true. We're going to set this to false. And if we click play now, we can see that these boxes are now drawn in play. We can see when the player overlaps with one of these boxes, hello is printed again. That's perfect. So now we know that there is actually functionality being fired when the player hits one of these boxes. There's a bit of a problem though. There is a bit of a problem. I will show you something that is not good for us. I'm going to add a sphere to the scene. This is a regular sphere, not a blueprint of any sort. And I'm going to turn on its simulate physics. What this does is when we press play, it's going to fall to the ground and have physics, right? And we can even run into it and push that ball around. The issue here is that this is now a dynamic object. And if it overlaps with one of these boxes, I'm sorry, it is not dynamic. That is a static object, but I can change it to dynamic for the sake of this testing. I'm sorry, I don't think it is. Let me show you something that we don't want to have happen here. It is not occurring. It is not occurring. I was going to try to show you that we actually don't want this to occur because it would trigger this hello event as well, but it is not, because it is not considered a dynamic object. That is my fault. Let me see if I can get that to trigger in some other way though. Okay, that is not firing. It used to fire. I guess they fixed that in a recent engine version. That is a good thing. What I was going to show you would be a bug, but they have fixed the bug. It used to occur back in Unreal Engine 4. I guess it does not occur anymore. Never mind. Ignore everything I was about to say. But we still want to test whether or not the overlapped actor is the player, right? Because pretend we have NPCs, maybe we have some zombies walking around this level. Those would be considered pawns as well. We don't want those triggering the coins and giving the player score. Maybe you do in your game, but in our game, we only want the player to be able to score in this game. And that's a very important test that we need to run. So let's jump back to BP Coin and ignore everything I was just trying to do. Go to the event graph. And we can see a whole bunch of options that come with this begin overlap event. We can see overlapped component, other actor, other component, other body index, from sweep, sweep result. Some of these are not relevant to us. The only thing we want to know is the other actor. In this case, other actor means the actor that has triggered this overlap event. And we want this to be the player, right? Not some zombie or whatever. What we can do is we can drag out, this is an actor object reference, and we can press equals. And we can check if this actor is equal to the player. So from this other equal checker, we can type get player character. And this returns the pawn for the player controller. The pawn in this case is the player itself. And we can see this has a Boolean output, right? True or false. Is this the player or is this not the player? From here, we can drag out and we can either type in probably if, and this defaults to branch, or you might know it if you use blueprints a lot as just simply branch. This is an if node, right? If true, do A, if false, do B. Let's disconnect these and connect these up. Now, if the other actor that is overlapping and triggering this event is the player, we can print hello. Now, from a functionality standpoint, compared to our initial setup of this, nothing has changed. But we have made this a bit safer for the player and for the rest of your game so that only the player is able to trigger this event. And if we press play and we run into these, we can see nothing has changed. Let's delete this hello because we don't want it to print hello to the screen when the player scores and when the player picks up one of these coins. Instead, let's drag off from true and type in destroy actor. As this sounds, it destroys whatever actor is hooked up into the target. And in this case, it is self, meaning the coin will destroy itself when the player interacts with the collision. And we can see that by walking into one of these, and the actor is destroyed. There's now no more coin there. And we can do this with each of the coins that we have. Technically, the player has now collected the coin. We don't have a score attributed to it. We don't have anything special happening. We can't even see the score that we have, but we do have it so that when the player interacts with the coin collision box, on true, we destroy the coin itself. Give me a second to drink. So let's start to set up the score and display it to the player. We have the basic functionality of the player actually running into the coin, and that's a good start. That is a very good start. Let's go back to our content browser. August, thank you for the raid, man. How you doing?
AUG16 Ferated Stream with 1 viewers.
Thank you, I appreciate that. In the core folder, let's right click. Now we're gonna go to create advanced asset down here, and in the blueprint section of that, we can create a blueprint function library. Now this is a very, very useful thing for games. It is a set of functions of reusable code that you can call from anywhere in your game. You can call it from the player, you can call it from the coin, you can call it from a widget, from like a HUD widget, you can call it from anywhere. We're going to create one of these function libraries and create the scoring system from there. And as you can see here, blueprint function libraries are containers of functions to be used in other blueprints. They cannot contain variables. They cannot inherit from other blueprints. They cannot be placed in levels. They're simply sets of code that you can call from the rest of your game, and you can use that to communicate with other parts of your game. So let's make one, and let's call this BPL blueprint. I'm sorry, Oh, I don't remember the correct prefix for this. Let's just call this tutorial function library. I'm sure there's a proper prefix for this. I cannot remember what it is. The prefixes are not necessary, but they are kind of good practice, right? In tutorial function library, if we double click and open that, we can see that right from the bat, it wants us to make a new function. Is it BPFL? Okay, let's rename it to BPFL to be proper. BPFL tutorial game. Thank you for that. So we have a new function. Let's rename this over here. And we can see that we don't have the same sets of availability that we would have in like a blueprint. We don't have graphs. We don't have events that fire. We don't have any variables that we can make in this. Let's rename this to add score. Simple as that. We can compile and we can see that we have add score. Now, if you remember back, we created the score variable in our game instance. This is where we intend to store it and to intend to grab it. Similarly, in our first person map, we can actually just copy these and paste these into our function library. Now, this node might look a bit different. It's fine, it will still function the same way. We're grabbing our game instance, treating it as tutorial game instance, and then grabbing the score that we have here. Now we want to grab the score and we want to add a certain value to it, right? The score to add. How do we do that? If you click on the base function node, we can see that we do have a details panel for it, and we have what's called inputs and outputs. Think of this like a machine, right? That every machine requires something to be input to it, like let's say a sheet of metal. And the output is the modified sheet of metal. Maybe you punch holes in it, maybe you form it into something, and you send it to another machine. That's pretty much what games are, right? There are sets of functions of machines that turn inputs from outputs. When you click to shoot a gun in a game, the input, your left mouse button, is being interpreted and being sent to various aspects of the game to, okay, fire bullet. play sound effects, play visual effects from the gun, and then the bullet itself will travel and perform its certain data to the enemy, right? Where did it hit? How much damage did it deal? Did it kill the enemy? Are you running out of ammo now in your gun? Now we need to display that on the UI. Things like that. If you're out of ammo, should we allow the player to shoot? No. So in this case, we want to take the score that we have in our game instance, right? And we want to add a certain number to it. So we want an input to add score to know how much we want to add to the player score. So let's click inputs, and we can press the plus icon to add a parameter. When we do this, you can see that a parameter is added to this function input. New parameter, and it is a Boolean. If we go into our BP coin and we right click and we type in add score, we can see our function from the BPFL tutorial game library. And we can even press it, and now we have this function add score with the new parameter as an input. Now in this case, of course, we want this to be an integer, right? Because we want a number to add to another number. So let's click integer and let's type in score to add. And I'm not going to use any spaces because as long as you use capital letters for each of the words, Unreal will automatically add these spaces for you. And it's kind of good practice not to include spaces in your variable names. It's just good practice, don't do it. Back in BP coin, we can see that that has also updated to score to add, and default is 0. We might not want that to be 0, but for this case, we'll just leave it a default 0, and we can even connect this up here, score to add 0. So now before the actor is destroyed, we're going to add a score to the player's score and then destroy the coin. We don't want to do it after, of course. If maybe you hook it up afterwards, this would destroy the actor and then it wouldn't run this code because the actor is no longer relevant, and this would be improper order of events here. So before we destroy the actor, which should be the last thing that we do, we want to add the score to the game instance and then destroy it. So how do we do this? So as score, now that we have this variable in the function, we can right click and we can type in score to add. And this is calling the function variable that has been added. And since these are both integers, they can have math used on them. We can press the plus sign or type in add. Either will work. And the default operator can be used to add these scores together. Now, for the sake of it, let's print this score just like we would before by typing this in. Dragging and converting from a integer to a string. We'll compile. Come back here and let's add score to add 1. Now you will see 1 displayed in the upper left. The problem that you have noticed is that it keeps saying 1, even though we should be adding these together. That's because we need to set the score as the output of this addition mathematical operation, right? So from tutorial game instance, if you remember what we did before when we typed in score, we could see 2 different options. We can get the score or we can set the score. Well, we want to set score equal to the output of the operation. Now we are saving that score as that output. And every time we call this again to add a new score, it's going to first grab the current score, add in the new amount, and then set the new score equal to the old score plus that amount. So let's try printing now the score now that we have this proper addition being done. 1, 2, 3. Perfect. Let's keep that print string in there for the time being because we don't have any other way to display the score. We're going to drag off from print string and do a return node. Now, usually when you're making functions, you want to, if you have a return node, you might want to return data, right? Because if you have a machine, right, and you have that metal sheet and you're stamping it or something, maybe after you stamp it, you want to form it into like a bowl or something. You would want to output the stamped metal sheet into another function, another machine that forms that bowl. In our case, we don't have anything to output, right? We just want to manipulate that data and then store the outcome. So we have manipulated it here, and then we store it here, all within the tutorial game instance. Let's make a new function called getScore. So you can see I clicked the plus sign to add a new function. We have named it getScore. This will be very similar to this. We're going to get game instance and the score. Let's copy these 3 nodes. Connect the execution. Now we know that the cast will succeed. So let's type in return. And what we're going to do is drag score into the return node. And you can see that it will automatically create an output for the integer score. You can also do this manually by clicking on either the start node or the return node and pressing outputs and adding in any new variable that you want. So now we have 2 functions. We can add the score and we can get the score. And in any blueprint that we have, we can call these 2 functions. And we can see that one is meant to update the score and one is meant to grab the score. We're going to use that later in our widget to display to the player how much score they have. That way we don't have to communicate between a coin and the widget and say, okay, in BP coin, update the widget to show the score. Now, because we're storing that information up here in the game instance, we can just grab that information from the game instance and reduce some of the complexity in our blueprints, where you might have this weird string of calls that it's very easy to make kind of spaghetti code that way. Getters and setters are kind of the core for most games. If you have a good place to store information, all you need to do is have 2 functions. One to update that information and another one to grab that information. So let's say that we want coins of different values, because right now we do have the core functionality of running into coins and picking them up, right? They're just being deleted, and updating the player's score. And right now the player's score is always going to be that value. How do we edit it so that instances of blueprints have different values? Well, let's take this add score variable, right? Or I'm sorry, this add score function, and we see this input variable of this integer, score to add. We can drag off from this, and what we can do is we can promote this to a variable. And we can see down here in the bottom left, score to add has been added as an integer variable in the blueprint. And if we compile, we can see that score to add now has that variable of 1, so it has transferred over. We can change this to 2 or to 3 or something, and just like it would work when you didn't have these connected, we're now just telling it via a variable on the blueprint itself what that amount should be. So now it will go 2 or 6. If you click on this variable, either over in the variable panel or on the variable itself, you'll see the details panel here again. We're going to be selecting a Boolean called instance editable. And this determines whether this variable is publicly editable on instances of this blueprint. If you remember correctly, each of these in the scene are instances of this blueprint. And we have demonstrated how you can modify these instances separately from one another. In this case, when we set score to add to be instance editable, you'll see a little icon over here on the left, a little I. Variable is public and editable on each instance of this blueprint. What does that mean? If we go back to our map and we click on each coin, we can see now in the details panel of that coin, this score to add variable is exposed to you, to the game developer, and each of them right now is set to 2. Let's set these to 1. I have edited this instance now of this coin to be worth 1 score, but these two are still worth 2. We can set this one to 3. Now you can see we have 1, 2, 3. Now if I run into these, if you look in the upper left-hand corner of the plane editor, you can see it says 1. And if I run into this one, it should show 3. And if I run into this one, it will show 6. Because 1 plus 2 plus 3 equals 3 and then 6. We have now created a system for us to have instance editable versions of these coins, and you can make coins of different values now. You could even edit the coin mesh to have a different material than the others. We're just going to shove something in here. And you can see that we can make coins of different values, maybe worth more. Maybe we want one to be like kind of goldish or some sort of different color. We can just, again, use some defaults here. But this is kind of a crude way to handle it, right? If you have hundreds of coins in your game, you don't want to have to edit each one by hand, right? It's just not, it's not great. So let's set this back to that default white material. And we can leave the values as they are now. That's not really super relevant to us. We're going to be adding in a bit of a deeper functionality, right? And we're going to be using a data table to accomplish that. So in this case, we want to make a data table that can say, okay, we want copper, silver, and gold coins. And copper coins are worth 1, silver coins are worth 2, and gold coins are worth 3. Let's jump back to our tutorial folder and make a new folder called data. And if it didn't autosave while I was typing, I would have been able to finish that. There we go. Sometimes unreal, man. Okay, so let's right click and we're gonna make 2 new variable types. Up here in Blueprint, we're gonna be creating what's called a structure. To describe a structure simply, all apples are fruits, not all fruits are apples. And when we want to describe what a fruit is, maybe it's how sweet it is, how many seeds are inside of it, what color the skin is, maybe a different shape of the fruit, right? We can use a structure to define these properties that all fruits will have, even though the properties of each fruit will be different, right? The values of these properties. So in this case, we're going to be making coins that can be described in the same way, even though the values of those descriptors, and in this case, might be the color of the coin, the value of the coin, will be different. So let's call this, technically the correct prefix is S underscore. I use ST underscore. Use whatever you want here. ST coin. And you can think of a structure, when you're creating a structure, as if it was an isolated version of this variables section that can be modified. So when we double click on that, we have this blank Boolean value. This is not really relevant to us. Another way that I can describe this is the column definitions of a spreadsheet. So when you're making a spreadsheet, if I can load one up here. You have columns and you have rows. So you might have a fruit, and like we said, there's a sweetness, number of seeds, color, shape. These are all things that you would put into a structure to define what that would equal. And then you might have a apple, an orange, a banana, a tomato, because they're fruits. That'll rile some people up. And you can then define, okay, sweetness of apple is, let's just say, let's just determine it by like calling it high, high, medium maybe, and low. You know, you might have different values for these, but you can all describe them in the same way. That's a classification. So in this case, our coin is very similar. We want to create the columns that define our coins. Number one would be score. Simple as that. We can then add another variable, and let's call this the color. So in this case, we're going to type in linear color, and we have a linear color structure. This is an RGBA color. So we'll call this variable color. And is there anything else that I want here? For now, this is a good start. What color is it and how much is it worth? Again in data, because we have the structure here, we've defined the column, we now need some way to describe the types of coins we have. So let's right click and we can make our spreadsheet, in air quotes here, by going up to miscellaneous and finding data table. Essentially, as it describes your imported spreadsheet table. And we need to pick the structure that is representative here. In this case, it is st coin. And we press OK. Let's type this dt underscore coin for data table. So we have st for structure and dt for coin. So we've essentially described the columns of the spreadsheet, and now we have made the spreadsheet itself. And if we double click on dt coin, you can see here, let's just expand these a bit. We have three columns. The default row name. So this is, in this case, the name of the coin that we want to refer to it as. We have the score and we have the color. If we go up to here and we press add, so we can add a new row to the data table, we can see down in the row editor the score and the color that we can describe it as. So let's make this row name, we wanted bronze coins, bronze, silver, and gold, right? Bronze. We'll make a new one called silver. Another one, double click on row name and type gold. Now it's good practice in row names to use lowercase letters, but it should be fine if you use uppercase. You can also use underscores, so you might want to prefix these by calling them coin underscore bronze, coin underscore silver. The reason you want to do this is that, to describe it simply, row names are a very efficient way to call data. You can have thousands of row names in a spread in one of these data tables, and it's a very efficient lookup for these, but you should have them be unique. So you might have tons of data in your game. You want your row names to generally be unique. And it will warn you too if you try to add in one that is named the same. So if we try to add another coin gold, it's going to say coin gold is already used as a row name in this table. So it's just good practice, you know, try to name your rows in lowercase with underscores and make them unique. So let's go up and let's edit coin bronze. Coin bronze is worth 1 score. And we can double click on this color and we can make it bronze of some sort, right? Let's go to, what's a good bronze color? Like copper, it's bronze, copper, whatever. Color like this will work just fine. So we can see that coin bronze is now worth 1 score and is given this color. Let's do the same for silver and gold. Silver is worth 2. And that color will be a grayish. And coin gold will be worth 3. And have a nice gold color. See if we can make that gold. It's a little bit too close to bronze though, so let's make bronze a bit reddish, a bit more red. Yeah, like that. So the question now becomes, we have the data, we have the structure, we have a defined way to say if the coin is set to bronze, it should be worth 1 score, and the color should be this color, the color of the coin itself. Let's jump back over to BP coin. And we're going to make a new variable for this. And we're going to call this coin data. The variable type we're going to call a data table row handle. We will compile, we will save. And if we expand coin data, we can now see that it's looking for a data table and the row name of that data table. Let's set this data table to DT coin. And the row name, if you press that now, you can see that we have our row names actually available here. Coin bronze, coin gold, coin silver. What we can do is we can actually make this score we're just going to delete this score to add. We're going to get rid of it here, and we're going to delete it here. Because now we have a data table that we can call this information from. How do we do that? So let's move the add score and destroy actor a little bit to the right. And drag off this coin data structure. Now we don't have a whole lot of options available to us when we drag this out. Certainly not anywhere near the amount of options that are available if we drag from this player character, this other actor, or any sort of integer or boolean. We have tons of options available. But this is because we need to break this structure. It is already defined, and there's not a whole lot that we can do with it because it is a custom new structure. We need to break it and grab the data that's inside of it. And we can type break data table row handle. I think, hold on, let me check one thing. Just real quick. Don't think this is, yeah. So we now have the data table and the row name. This is a data table object reference and a fname name of row in the table that we want. We can drag from this data table and we can type in get data table row. This attempts to retrieve a table row from a data table via its row name. Well, the good thing is we have both of these right here. Data table and row name. And we can just connect these up. And what this is going to do is in any instance of coin, of our BP coin in the scene, it's going to grab the information from coin data. It's going to attempt to grab this information from this data table and return the values that we expect from it. So let's compile and save and hook these up. So when the player runs into the coin, excuse me, when we compile this, it's going to give us an error because the type of out row is undetermined. We need to connect something to it to imply a specific type. So in this case, it doesn't know what data table we're actually getting here, right? Because that's determined by runtime. We might change the value of coin data to grab a different data table. We don't want to do that, but it doesn't know that. So we need to tell it which row name we're expecting. So in this case, or I'm sorry, not the row name, but the type. In this case, it is st coin. So we can type in coin, and we can do break st coin. And if we compile it now, this error is gone. And because we know that it's always going to be a coin, we have our two variables here. We now have score and we have color. We can hook up that score to add score, assume that the row is found because we know that it will. And if we press play again, I'm sorry, we can't do that yet. Make sure to set DT coin, the row name here, to something just like, let's say coin bronze for now. So all the coins in the game are going to be considered coin bronze, which are worth 1 each. 1, 2, 3. Now we can make this instance editable again by selecting instance editable, coming over to the map, and we can see that coin data is now a editable variable, and we can set this coin to be bronze, this coin to be silver, and this coin to be gold. And much like we had before with the 1, 2, 3, we now have 1, 2, 3. 1, 3, 6, because we're adding them, right? The benefit of doing it this way over the way we did before is that we can create a whole bunch of coins, and maybe we want to change the values of every gold coin in the game. So let's say we have a whole bunch of gold coins. We can now just go over to this data table and we can change the value of all gold coins in the game without having to touch a single one of them. And we'll just say they're worth 5 each now. We'll save that, come back to the map, and now we should have 1, 3, 8, 13, 18, 23. Simple as that. We can also add more coins to the game this way. So we could just add maybe a platinum coin. Or let's think of one that is maybe a bit, maybe like an iridium coin. So this will be purple. Coin iridium. For all my Stardew fans out there. And we'll change this one to be worth 10. Color, a nice, obnoxious purple color. Beautiful. So we've now added a new coin to the game, and we can say, okay, well, we have this 4th coin here. Let's change this one to iridium. Simple as that. But you can tell that they don't really look like their proper colors. We have this color information, but it's not used anywhere. So how do we do that? Well, let's come back to our tutorial folder, and let's make a new folder called materials. And we're going to be making a new material in there. So right click, and in basic asset, we can type in material. And let's call this m_coin. Now, I'm not going to be jumping into the specifics of getting too crazy with materials, but materials can be, you can make some really amazing materials if you are skilled as an artist. I am not, so we're going to be keeping it simple. We have here our material. It is black. It is nothing. There's no data hooked up to this. For the sake of keeping it easy, we only really want to worry about the base color here. This is the basic color of that material, and a material or a color could be described in 3 bits of information, right? The RGB values of that color. So that is a vector. So we can either hold the 3 number key and click, which will create a vector, or we can type in I think a constant 3 vector, same thing. And we can drag from here, this is the RGB value, the 000, or you have here specifically the red, the green, the blue. We want all 3 colors, and we can connect this right up to base color. And of course, we can see that it's black. Now, if we double click on this, we can select our color picker, and we can change this, and you can see the material color being updated to reflect the color that we've set. Right now, it doesn't matter. It doesn't matter what we set. So let's just set this back to white. But we're going to right click on this and convert it to a parameter and call this parameter color. So just like with blueprints, you can have materials that are instanced, and you can modify the parameters of that instance, just like with our coins. So what our goal is, when we create a coin, we use this material and we tell it, hey, by the way, I know the material you're using, it has a parameter called color, and I want you to update the values of that color to the values that we want based on our data table. So let's jump back over to BP Coin, and we can set the coin mesh materials equal to coin. And it's going to look very similar to what we had before, right? They're just white coins for now. We're going to come over to the construction script, not the event graph. Now, the difference is that this is very similar to the event graph, but this is run in editor. And this is a great way for you to visualize changes in your blueprints as you modify aspects of them right in runtime, right there in editor runtime, as opposed to waiting for the game to play in order to see those changes. Because of course we could set the color of these coins during gameplay, but then they would still look white for you when you're editing. And that doesn't really make it easy to edit, right? Because you don't know what these coins are worth. So instead we can edit these while you're still in the editor. So let's grab this coin mesh, we can drag it over to here. And we now have our static mesh component reference. And we can drag out from that, and we can type in create dynamic material instance. Now technically we could grab the material that we already know, but we can just type in coin here and we can see our M coin. Now this is what this is doing, is creating a material instance for that material, and then we need to set that coin's material as using this. So we can, just for the sake of keeping lines simple, we can copy and paste coin mesh again, and we can set material. Target is primitive component, and the material we want to be equal to this return value. Like this. Now if we compile and save again, they will look like nothing, but they are using our new material instance. They are copies of that material, individual for each of these coins. Now because we have this dynamic material instance, we can say, okay, I know that you have this parameter called color, so let's set parameter, set vector parameter value, because it is a vector, it's a color, right? And again, for the sake of this, we will keep nodes a bit separated. I'm double clicking on the line, by the way, to create redirection nodes. These are a great way to organize. We can do that. And now we have this color value. And if I move this over to red or something, you can see that, I'm sorry, that's not working, because I need to actually type in the parameter name, which is called color. And now if we compile, we can see that all the coins are red. And as I update this, so too will they change in game once they are compiled. Boom. So we want this equal to the color value that is specified in coin data. So let's do the same thing that we did before. Let's grab coin data, get, we're going to break the structure. We're going to get data, table row. We're going to break st coin. And now we have this linear color structure that can be connected up to this linear color structure. So let's make a little bit of space in between these, because we need to grab this data before we can set this parameter value. Still need a bit more space, but we can connect up the execution first. Try to get these in the right space. There we go. And I will move this down a bit. There we go. So let's connect up the color to the value. Now, if we press compile, and we come back to our map, we can see the colors being applied correctly to each of our coins. And now if we drag out a new coin, default will be bronze, but we can very easily change that to any color. And as we do so, it's not only changing the value of that coin in the background for us automatically, it is also updating the color of that coin for us in real time in editor. And if we play, we can see we have our coins working from a score perspective and from a visual perspective. That's pretty nice. That's pretty nice. And as I mentioned, you can just update this with a new, maybe like a super coin. Let's go coin, super. This will be worth 100. And I don't know, let's make this green or something, right? We'll just save that, come over, add a new coin in, and instantly, super. It is that simple. And now that'll be worth 100. We can move that in line with the rest of our coins. So now we have covered basics of blueprint communication, game instances, and how to store all of that data. We've set up a blueprint function library where we can add and grab the score. We've gone over data structures and tables, material instances and parameters as well. Our data, thank you for the follow. The last thing that we need to do is hook up a little bit of a UI for the player to actually see what score they have. So let's do that. Let's close everything for now. And close tabs to the right. We'll go back to our tutorial folder, make a new folder called UMG. Or UI, either works. Let's name it UI for the sake of it. And in here, let's make a new blueprint. Or I'm sorry, let's go down to user interface, where we can see widget blueprint. Widgets are what Unreal refers to as, things that you can put on the HUD, visual aspects like that. So we're going to make a new widget blueprint and select user widget, the basics, and call this WBP for widget blueprint underscore score. And let's double click this. Now, at first glance, this might look very similar to our blueprint graphs, but this is actually a visual representation of the screen. It's a little bit hard to see right now. They used to include a canvas panel by default in these, which made it a little bit easier to visualize. Let's add one. So let's go up here to the palette. And these are things like buttons, images, things of that nature. We just want to start by adding a canvas panel. And you can think of this as you would think of a canvas. We can either just drag it into the scene or we can drag it down here. And we can see now that this is our representation of our game screen. There's nothing there. We don't have anything. This is more of like a container that we can hold widgets in. And if you drag off from this, you can kind of see the different resolutions of different screens that you might want this widget to appear on. This is just for visual purposes though, to see how it would look at different resolutions of the game. So maybe you have resolutions that are closer to a phone screen and you would want to see how your widget appears for that, that vertical portrait orientation versus a more traditional landscape game orientation of 1080p. What is our score going to look like, right? Probably a text where we show score, colon, and then the number that the player has. So that's text, right? Let's go up here and let's add a text to the screen, and we can add this anywhere. For the sake of purposes of showing you what it looks like, let's just keep it right there. Let's just say text block. It's kind of near the center-ish of the screen and up and to the left. Let's compile. And now when we press play, nothing's going to appear on the screen. We haven't told the game to show this widget on the screen at all. But we can do that via our level blueprint. Let's come back here and let's delete these things. These are old. We don't need them anymore. But we do want, on begin play, we want to create a widget. We want to show this widget on the screen. So let's come up here and let's do create widget. And you can see that this will attempt to construct a widget of a specific class. Well, our class is called WBP score. And we can see it here. If we see this, if we click on this list, we can see WBP underscore score. Now again, if you press play, this will not appear on the screen yet. Because we are creating it, it is added to memory, but it has not been told where to appear. Thankfully, this is very easy to handle by dragging off from the return value, so the constructed object, and typing in add to viewport. Adds it to the game's viewport and fills the entire screen unless set desired size and viewport is called. So this is great. What we can see now is if we press play, it has been added to the viewport. We have the basics of our HUD. And that's all we need to do there. All we need to do is say, yes, we want this displayed on the screen, and it should always be displayed on the screen. There it is. So we have the text block. Let's move this up to the upper left somewhere maybe, where we can display the score. I'm not going to be too specific about getting it perfectly positioned, but you can if you want. And we can come over here to the details panel of that text block, and let's just call this score : and then I'm going to put a space afterwards. So now if we press play, we can see that it does now show score up here, and of course we don't have any score, and it's not going to show anything if we run into it, right? It still shows our old debug numbers. For the sake of clarity and making this a bit easier for us to manage, let's put this text block into another container called a horizontal block, or horizontal panel, sorry. So what I can do is I can either come up here and look for the panel myself, horizontal panel. This allows widgets to be laid out in a flow horizontally. So you can think of this, I'll just draw on my screen here. If we want to have a list of, like icons in a horizontal way, we can have them listed in a horizontal panel. There is also a vertical panel that you can use that would display them on top of each other. But for our case, score and then the value, we would like to be separate, and we can lay them out horizontally. So I can throw this horizontal box into the scene, and we can put over here in the hierarchy, I'll just drag this out so you can see it. We can make text a child of horizontal box. You can see it is now within that horizontal box. You can also right click and you can wrap with, and in this case you can then select horizontal box, and it would put it in a horizontal box for you there too. I like doing that because it's a little bit faster, and I don't have to look for the panel up here. Let's make a new text block and put it into the horizontal box as well. And you can see that these are all part of that same horizontal box here. Let's press size to content so that it correctly sizes it to what we have in there. And if we drag around this horizontal box, you can now see that it drags both of these along with it. So let's move this up here. Now this second text block, we want this to be the score. So for the sake of visualization in the widget, let's just type in, some numbers, right? If the player were to press play, they would see these numbers up here. But of course, they don't have any relevancy because we haven't hooked up the functionality to this yet. We want to bind the number to this. We want this to be updated every time the player runs into a coin. Now there are a few ways that we can do this. I'm going to show you the easiest way, but it is not always the best way, and I will explain why. Over here in content, we can see this text, and we can see this little chain link symbol next to it. This is a binding. So what this means is if we click it, it will create a new function and create a new binding. that will bind the contents of that text block to a value. Now, if we were to press play, it's nothing. And it is updating that every single frame of the game, every single tick of the game, it is updating that value. To, in this case, nothing, because we didn't set it to show anything. The reason why this is the easiest is because anytime we update the player's score, we can just grab the value of that score and show it on screen. The danger of this lies is that it is updating that every tick, but the player is not getting new score every tick. So we're actually running this update in a less efficient but simpler manner. Now we don't have to fool with specifically telling the widget to update, making a new function to update it with the new score. We're going to be doing that every tick. I will show you this way, and then I will show you the proper, little bit of a better way to do it by updating it via function. So that's, we'll handle it through both ways. So the easiest way to test it for now is to use our function that we made a long time ago called getScore. We can call that here too. And we can simply hook this up and then connect the score value to the text value. Text is a little bit different than a string, but they are very similar. Text can be localized, whereas strings cannot. Strings are easier to manipulate compared to text. Generally speaking, though, the conversion between text and string is pretty cheap, but you may want to just notice that this is a text value, not a string value. Those are two different things. And if you want to manipulate, like append two pieces of text together, or find an inline, change like a word inline, you will want to use string, not text, but you can always very easily convert these over to string and then back to text if you need to. But for the sake of this, integer can be converted directly to a string, and we can just hook this up, get score to text, and the return value will be updating that score right in real time here. 1, 3, 6, 16, 116. It's that simple. It is that simple. And, for the sake of this tutorial, for the sake of a game that is this small, it is okay to be updating this every tick. It's not that big of a deal, but there is a more efficient way to do it, and we're going to be showing that to you right now. So let's say here, let me think, there's a couple ways that we can do it. And the simplest way is to probably do a get all widgets of class. So there's a node that you can use that will grab all the widgets in the scene of a specific class. We know that we're only going to have one score widget in the game. It's a single player game. There's only one score widget. We're never going to have more of that. And so doing this is a pretty simple and cheap way to grab that. You might want to avoid doing that in a larger game where you might have, maybe multiple players, in which case you need to specify which player you're calling it from and which thing they have, but we're not worrying about that right now. This is just a very simple tutorial. So let's go back to our function library back in core. And when we add the score, we can delete this print string now because we have a way to visualize this on the screen. Once we have set the score, let's get all widgets of class. We can uncheck the top level only. This will just help us to look for everything that's in the scene. And we need to specify what class we're looking for. In this place, let's grab the score widget, WBP score. And from the found widgets, it is always going to be an array, but because we know that this is always going to be, only going to be one, we can just grab the first index of that array. Let's type in get. And this is grabbing a copy of that widget. That's fine. at index 0. If you're unfamiliar with arrays, you can think of an array as a box of items, right? And you can keep filling that box with items of the same type, right? So if it's a box of apples, you have 2 apples in there, you can add another one, or you can even have a box of fruits. Like we've been using that analogy before. You might be able to add an apple, add a banana, add an orange, and in this case, we are grabbing an array of all of the WBP score widgets in the scene, which we know is only going to be 1. And in this case, the first item in an index first item in an array is index 0. That's very important to remember if you're new to like programming logic. It is always 0 in an array. If you try to grab index 1, that is actually item number 2. Might take some getting used to, but that's how arrays work. So as this, we could then call any sort of functionality from WBP score. The problem is we don't have any functionality except for this getText function. So let's make a new function in this widget called updateScore. Now there's a couple ways that we can do this. Let's say for the sake of it, we don't want to have to run the getScore function again, but we could always just grab the score and display it, and then update the text value with that score. Let's do it that way for the sake of ease, because we already have this function, and I think it keeps things a bit cleaner. UpdateScore will grab the player's score, and we need to be able to grab this text block. So let's make it a variable, and we can do that by checking this check mark in the details panel right next to the name is variable. And let's rename this to t_score. Compile and save. And if we come over to the graph, we can see that t_score is now a variable that we can use in our functions. So let's grab off of this and set text. This sets the text very similar to you would see here, this return value. We just want to now do update the text value of that equal to the score from our getScore function. We can connect those up, try to avoid the spaghetti best we can, and then do a return node. Simple as that. Now, unfortunately, this will not do anything because we don't call this function anywhere. We don't call updateScore. But we can do that very simply by coming back to our function library. And in this widget, we're going to be grabbing the first one that we find and telling it to update the score. And then we can hook up our return node. So let's go back to WBP score, back to the designer, and let's unhook the binding that we created before. So let's remove binding and set the default value of this to 0. Now we can come back to the graph and we can delete this getText function that was created automatically through the binding. We don't need it anymore, it's not used. Now instead of updating every tick, the score will only update when we specifically ask it to update. And this is a bit more efficient, even though we are adding more lines of logic to it. You may not want to do this in the case of like health bars, right? Or if there's a timer on screen, you want that to update every tick, and you don't want to have to call a function every tick because that's kind of, it's technically the same thing, but it's a little bit easier just to bind it to a value that you know might update or might need to have a more granular visualization, right? Like that, right? So like timers, health bars are great for that. Any functionality that you will expect to have on the screen at all times, and it's okay and cheap to quickly update that value every tick. So now we have this. This is working. We've appended this to the add score function, and now we have this score. And in the upper left, you can see it's working exactly the same way as before from the player's perspective, but behind the scenes, it is a little bit more efficient. So we pretty much have almost all of the game at this point, except for one thing. We don't have any win scenario attached to the game. We can do that by adding in another bit of UI that is called when the player's score surpasses a threshold, right? So maybe we can set up some data table that determines the balance of the game and how much score is needed to win the game. And then what we can do is, show that screen and allow the player to choose those two options, either, restart the level or quit. So let's come into here into UI and let's make a new widget. Same way as before. And let's call this WBP windscreen. Let's open this up and add the canvas panel that we added last time. Just a good way to store things on the screen and to plop things down. And I want this to be a bit dark, a bit blurred, and for, the big text in the screen to say you win, and then there's two buttons below it, right? So let's think of this in terms of visuals. Number one, we want a background image across the entire screen. So let's add an image. Let's come up here to anchors, and let's anchor this to all four corners of the screen. Now in the offset, we can set these to 0, and now we have this big, beautiful, giant white box on the screen. We can come down here to the color and opacity, set this to black, and change this to be kind of see-through, right? Maybe 0.4. We can do this exact same method for a blur. So if we type in blur, there is a background blur effect. We'll set the anchors to all four corners again, 0 the offsets, and set the blur strength to something like 2. Little goes a long way in blur strength. It gets very, very blurry already, even after small values, and anything larger than that is kind of absurdly blurred, in my opinion. So if we come back to the first person map and we do the exact same thing as before, create a widget, and we add this windscreen, and we add to viewport, we're going to start this game and it's going to be black and it's going to be blurry, as we can see here. Obviously, we don't want that appearing at all times, but we can see what it kind of looks like when the player would have that on their screen. So let's delete those. Let's come back to windscreen and let's add a text box right into the canvas panel. Let's move that in, size to content, for the sake of moving around easier. Let's change this to you win. We'll come here under the font settings of the text block and we can increase the size of that. And we'll just roughly center that in the screen. If we want to get it more centered properly, we can actually change the anchoring to the center of the screen. And then if we 0 the position here, you can see how it aligns that to the upper left of the text block. We can adjust that by setting the alignment of that text block to 0.5, 0.5, and now it is centered directly into the screen. And this would be the case even if we change the screen resolution, right? So if the player is playing in a widescreen or something, you can see it's still centered in the screen there. We are going to offset that on the Y value, let's say negative 200. So it is centered, but a bit near the top there. Let's add in a horizontal box now. To the canvas panel, size to content again. And this time, let's add 2 buttons to this horizontal panel. You can see a button is added up here, and another button is added next to it Of course, they have pretty much no space between them. So, hey Dremox, yeah, it's tutorial day. I didn't want to ruin the tutorials too much with fart sounds, tempting as it is. So it would be good if we had text within this box. Now, the way that we can handle this is that buttons can have one child in them. And in this case, we're going to add a text box to each of these buttons. So we can drag text down, and on top of the buttons, if we drop them in, we can see that the buttons now contain text blocks. And our horizontal block here, or box, sorry, we can move around the screen just like before. Let's anchor that as well to the center of the screen. Zero it, align it. And now let's set the Y position to positive 200. So now the uwin text is negative 200 from the center, and the buttons are positive 200 from the center. So generally they'll move around the screen in a very similar way if the player is playing on a different resolution. Let's come down here and change the buttons to restart and quit. And down here in the appearance, we can change the colors of those to black to have better contrast with the gray buttons. Of course, you can always change the look and feel of the buttons yourself, but for right now, we'll keep them default. Now, it would be good if we could have some space in between these. There are a few different ways to solve this. For the sake of this, let's just add a spacer in between these. So there is a spacer primitive, and you can see that it's part of this horizontal box. We can change its orientation by clicking on it over in the hierarchy and moving it left in the box. And now it is between restart and quit. And we can change the X size of that spacer to, let's say, 300. So now there is some space between restart and quit. Now we have no functionality tied to this win screen. We don't even have it able to appear because we don't have any way to check what the player's score is and whether or not they have won, correct? So let me think of where we could handle that best. Probably in a game mode would be the best place to handle the checking of whether or not the player has won, and every time we add to the score, we should run this check. So let's go make our own game mode. Now the nice thing about this is that you can change out game modes at any time through our gameplay, and this does not affect the game instance, right? So you might have different game modes from like maybe mini games in your game. Maybe your game is a bunch of mini games, right? So maybe you have like a claw machine or a racetrack. You can switch out the game modes, which will change the what's the best way to describe this? Game modes define the player's pawn, the controller, other aspects of that specific mode's core functionality, and that way you could switch between those game modes and have different checks for whether or not the player has won that game, or run different logic within just that game mode attached to that player's pawn. Since, for instance, the player might control a race car in the racing game, but then when they're walking around the rest of the game, they're controlling the first person. So you would switch game modes in that case to move the player's pawn and control between different modes, but then have each of those modes functionality and logic tied only to that game mode. I know that might sound confusing, but think of it like an arcade, and each arcade machine has its own game mode. It has its own logic that gets defined when you go up to that cabinet and you start playing that game. In our case, because our game is just one game, it's just collecting coins, we would only have that static game mode where we would then check, has the player won, and if the player has won, show this screen. So let's go back to the tutorial and into core, and let's make a game mode. Let's go blueprint class, and you can see game mode base. Game mode base defines the game being played, its rules, scoring, and other facets of the game type. You could also store the score for individual games within the game mode as opposed to the instance, right? If you think of this like a arcade game, on Steam there's a game called the Coin Game, right? If you've ever played that, you would know kind of what I'm going to be explaining here. But think of like an arcade. When you go to arcades, you play games at different cabinets. Each of those would have a different game mode. But your game instance might store things like the player's number of tickets, right? Because those are separate from the game modes themselves. The tickets are the number of, global score that you have for your time within the arcade, and then you could spend those at the shop. So in this case, we want to make the game mode. We aren't going to handle scoring there, but we could. And if you have multiple different games in your game, you might want to use game modes as a way to separate the scores between those modes. So let's call this GM for game mode underscore tutorial game. And again here, you do have a viewport. We're not going to be using that, but you have a whole bunch of default classes that can be set here. Now, in our case, we don't have any sort of things to change here. The default pawn is fine. The player controller is fine. Nothing is different. But in this case, this is exactly where you would change it for like a racing game to change the player's pawn class or the controller so that they're now controlling a race car, and the inputs are different for that compared to the inputs of walking around the rest of the arcade. In the event graph, we can add functions for check player score for win. So let's just leave this here for now, and let's go define what the win scenario of our game is. So let's go back to tutorial data, and let's make a new structure. So remember we did that in blueprint structure, and call this st game rules. Let's open that up and let's just define, for right now we only have one rule, and that is the score to win. So let's make this an integer and call this score needed to win. And we'll make a new data table, or we can even use a data asset. Here's the difference. A data asset is like having one row of a spreadsheet. So if you know that you're only going to have one row, it's very good. The problem with data assets is that they cannot be imported or exported. So I still prefer to use data tables even with one row because I can handle the balance of that in a spreadsheet. But just know that in this case, you could use a data asset, you could use a data table. I'm going to choose to use a data table because in my opinion, they are more flexible than data assets for this scenario, where I might want to have a separate spreadsheet to store rules of the game, and I could run balance calculations within the spreadsheet. So, don't do that. But you could choose a data asset if you knew that you were only going to have one row and a more rigid object with which to set your game's balance rules for. The nice thing is I could then, with a data table, I might have different difficulties of my game or different presets of difficulties, and I could just choose the row name of the difficulty that the player chooses and then update the rules from that, as opposed to data assets where I would have to have a different data asset for each difficulty mode. So there's no right or wrong way to do it, but there are different use scenarios that might make one more efficient or better than the other. So let's set this row structure as st game rules. Let's call this dt underscore game rules. Let's make a new row, and we're just going to call this default. And the score needed to win, let's say, is 100. Or, you know what, let's keep it small because we have smaller coins. Let's say 20. So back in our game mode, we have now the data table, we have the game rules. What we can do is we can kind of hard code this a bit and just say get data table row. DT game rules. And we're going to hard code this with the row name default because we only have one row name. But if you wanted to accomplish what I mentioned before with the difficulties, you might have a screen that appears when you start up this arcade game, for instance, right? Let's say, and the player chooses the difficulty that they want, the number of coins that they want to have to earn in order to score. You could then set that. Liren, thank you for the raid with 63 people. That's crazy. How are you guys doing?
Liren Strass raided my stream with 63 viewers.
I'm going to take that time to pour myself a drink because my throat's starting to go dry. You might use that screen where the player can select their difficulty to then call back to the game mode and say, hey, the player has chosen the hard difficulty, so please select the row name that corresponds with the difficulty they've set. And now when we choose to check for the player if they've won, we can determine if they have surpassed the threshold for that scenario. Give me 1 second, sorry. Gotta make sure throat doesn't get too dry. Okay. So check player score for win. We can break this row. Now, unlike before, we don't have to tell it which row that we're intending to break because we've already told it which table it is. So let's just type break and it's going to know exactly which one we want to break here, which is ST game rules, and we have score needed to win. What we can do is we can say get score and determine if score is greater than or equal to the score needed to win. And if that's true, because the player might surpass the score needed to win, right? By picking up a really good coin, we want to create that WBP win screen widget. So if true, we can create widget win screen, and we can add to viewport. Now we're going to click this little triangle down here to expand, and we're going to set the Z order to 99. This is the order on which the layers of the widgets are drawn on screen. So if you have two widgets that are on the same Z order value, they will draw and be visible like inside of each other, right? You might want to do this for certain elements. For others, you might want them to appear above that element. So like a good example is like a tooltip needs to appear above the widget that it is, that you hover over. Think of any like strategy game, right, that has a lot of tooltips. So that needs to be one Z order higher. In order for us to make sure that the win screen appears on top, we can just set the Z order to 99 and know that it's going to be the highest one on the screen. So that will appear over the player's score. And from this, we can return back to whatever we were doing before. And we can copy this because if the player's score is not high enough to win, we don't want to do anything, right? So we can just return from that. Back in our function library, every time we update the score, we now also want to check if the player has actually won the game. So let's move our return node over to the right some more. And let's get game mode. And very similarly to our tutorial game instance, we need to actually tell it what kind of game mode we have. So let's cast to GM tutorial game. Now these are kind of annoying to have to put everywhere. So let's think of a way that we can make these a little bit cleaner. We can make new functions called get game mode, get game instance, and we can put both of these nodes inside of there to make one node that we can call to grab this information, and these are very useful because there might be other cases in your blueprints, in your logic, that you might want to call the game mode or call the game instance, and you don't want to have to type this every time. So let's make two new functions. Let's call one get game instance, or let's type in get tutorial game instance, and one for get tutorial game mode. Let's go back to add score, and we will cut these out, paste these in, add a return node, and let's rename this to game mode. And similarly to here, we can cut these out, do a return node, and return the game instance. There we go. Now back in our add score, we can just type in get tutorial game instance, and we can save a little bit of strife and headache having to grab that every time, right? And then do the same thing for the game mode. It's running the exact same logic, but this helps us to organize a bit more, and it's also going to help us in the future if we wanted to add more content or features to be able to call from anywhere, get tutorial game mode, and we can just grab that in here too. So the more time you spend putting things into your function library and organizing those properly, you're going to save a lot of time and headache down the road, and you'll generally have a bit better time calling those strings of events that you need. So as the game mode, we want to do a check player score for win. That's it. That's it. And now if the player receives the score equal to the game rules, which will be 20 or higher, we will show that screen for the player. We have one issue with it though, however, and I'll show you exactly what that issue is. So let's pick up something that we know will win us the game. This. And actually, I forgot to even set up the functionality for that, so that's my bad. Hold on a second. We never told it what game mode to actually use, so we can do that in the map itself. I think we can also override the game mode in the project settings. Let's do it there for safety. So in maps and modes again, where we set the game instance, let's set the game mode equal to GM tutorial game. Now if we press play, everything looks the same, but we do have that game mode in the game, and we won't have that that filling logic there that was trying to grab the game mode but couldn't find it. The Frank 2, thank you for the follow. I don't know why that was not working. Let's see. I did not prepare for this. Let's see. Access on trying to read property. Get tutorial game mode. Why is that? Probably because the world is overriding that with a different game mode. That would be why. So we need to select the game mode class, or actually we can select none. And I think it will default. Oops. Hold on, there's a couple things we need to check with this. We do have the new game mode. The old game mode, however, was using the proper player controller. So we need to set that in our game mode too. So let's go back to the class defaults and set the default pawn class to BP first person character. That way we're using the character that comes with the first person template, but now we have that additional functionality that we wanted to have within our own game mode. So working like before, now we're using the correct game mode since the world isn't overriding it, and we have our win screen. The problem here is that the player can still move, and it is adding the win screen every time, and it's getting darker and darker. And technically we have like 5 instances of the U win screen. This is not the functionality we want at all. But we have the screen, we just have quite a few problems with it. We need to tell the game mode needs to say, okay, well, if the player wins, stop moving, get rid of the player's ability to move, and then make sure that we only do this once, right? We only show one of these screens. Though if we stop the player from moving, that should resolve it, but let's double check and let's make sure that this is only one run once. So what we can do to remove the player's ability to move is either pause the game, which probably is our best solution, or we can... There's a few ways we can do this. Let's pause the game, because that will prevent anything from functioning except for UI elements. UI is still usable when the player pauses the game, but it will stop all runtime events such as the player movement, any like enemies attacking. Everything will be paused just like you would expect it to work in the game. Now I can call pause game from this menu, I believe. So we can set game paused. And if we do this, when we run into one of these coins, the game is completely paused. Nothing is occurring. I can't move. There's no inputs. I can't even see my mouse. That's the last thing that we need to do, is make sure that the player can actually see their mouse cursor and interact with the UI when it appears. There are alternative ways to do this. So what you could also do is remove the player's input for movement and then set input to UI only. There's like 3 different ways that you can resolve this, but for now we're just going to pause the game and we're going to show the player's mouse cursor. So let's get the player controller, since this is where it is specifically controlled, and we will type in set show mouse cursor equal to true. And now when the player runs into one of these, we can see our mouse cursor and we can click on these buttons now. They don't do anything because we didn't set them up to do anything, but now the player is paused. There's nothing I can do in the game. I can't move or jump, and all I have the ability to do is press restart or quit. So let's set up the functionality for the restart and the quit. Let's go back to the win screen and let's rename these buttons that we made. So let's call this B_restart. And this one we will call B_quit. Save and compile, and let's go back to the graph. Now we have over here these buttons available as variables and images too. Kind of annoyingly, images automatically become variables, but you can always just turn those off. We're just using it for the background, so we don't need to modify that in any way. Under these, very similarly to the box that we made for the coins, we have some default events, and you probably can't see it because my camera's in the way, but you can see that we have events when we click on these buttons that we can put into the event graph. In this case, let's press the on released, and let's add both of these into the game. So B restart on released and B quit on released. So this will fire whenever the player releases the button. So that way you don't click restart and don't release your mouse and you're immediately thrust back into the game, or same with quit. It will wait until you've released the mouse button key. Quit's easy. Thankfully, this is one of the easiest ones to call, and this is just going to be quit game. And that's all we need to do. Quit preference, quit, done. So if we run this and we run into here and we press quit, the game will just end. And I noticed one problem that I have to fix with that. Yeah. We'll get that fixed. On released for restart, in this case, we probably want to just reload the level. That's going to be the easiest thing to do. So what we can type in is open level by, probably we can just do an object reference. And this will be our default first person map. And this should, we'll see what, maybe, you know, the player's input might not be fixed up, so we'll just see what happens when we press restart. The player still has their mouse, the win screen is reset, the score is reset, and everything else is back to normal. The only thing that we need to do is make sure that when the player starts the game, that we hide the mouse cursor, or in here when we press restart, we get player controller, and we set show mouse cursor to false. We might have an input problem still, and I'll explain what I'm running into with this and how easy it is to fix it. It is not hiding the mouse cursor, but we can fix that up. From player controller, we can do set input game only, and then hide the mouse cursor. So this is telling the player input to only respond to, you know what, we actually need to do this first. We need to set the input mode and the cursor before opening the level, so that by the time we open the level, the player's input is already fixed. The reason why is because by the time we open the level, it is resetting this win screen, and anything fired after it will not actually fire. So now we can press restart and the player is right back to normal. The issue that I'm running in is that when we open up that win screen, we're not actually telling the player to be able to focus on that. So similarly to set input mode game only, back in the game mode, we need to tell the player to have set input to UI only. And the widget that we can focus is in fact this widget that we've created, this win screen. So this will focus the player on the win screen. Oopsies. And allow them to only interact with that screen. Which should fix all of the input issues that we might have with both of these screens. And we'll do our best with the spaghetti on that. So now the player can run into one of these coins. We can immediately press restart, and we're thrust right back in, and the player's score is properly reset. Except that it's not. So remember this, the game instance sits on top of the entire game, right? And we mentioned that that's good because the score will get transitioned between levels. The problem is that the score is not being reset every time we press restart game. Now the nice thing is we can make a function for doing that, right? So let's go back to our function library and make a new function called reset score. We will get the game instance, tutorial game instance, and we're going to set score equal to 0. And now every time the player runs into this win screen, before we open the new level, we can simply call reset score. And that will make sure we don't have the issue where the game instance is not remembering that we've reset the game and therefore should be resetting the score too. Now we can run into this. We get a score of 1, score of 3, score of 6. This will make us win, and our score is currently 106, but we press restart. Now we're back to 1, and it isn't resetting each time. Now what we could do is we could place some of these coins around the map, you know, just like we've initially intended. Maybe some secret coins. And use our knowledge of Unreal Because these float above the ground, it might be annoying to have to align them all perfectly. What you can do is you can press the End key to snap that actor from its root right down to the level itself. So in this case, we can easily have things of different, maybe we want some coins along this path, right? Maybe some bronze coins. We can make a whole bunch of copies here. Drag them all up. And we might be able to press End on all of them, and they will get instantly snapped to the ground at the right height, which is very nice. And there you can see our very simple game with collecting coins of different values which are very easy to set and to modify within the blueprint itself via a data table, and a win scenario for the game if you manage to collect enough score to win the game. You can reset, you can quit from there, and it's pretty easy to modify and to expand. And that, hopefully, has taught you the very basics of communicating between blueprints, having game instances to store all that information, having a blueprint function library for grabbing and setting data between blueprints and between the game instance, data structures and tables to make modularity and scalability of your game much greater, material instances and parameters for updating instances of blueprints or materials on different parts of the world based on different parameters that you've set or want to use, and the basics of the UMG and how to insert functionality into it, as well as showcase data to the player from your game instances or from other aspects of the game itself. Hopefully that was informative for you guys. That did take about 2.5 hours, so it's about as I expected. And if you guys have any questions or you want to see me do anything, now is the time. But if you think of something later, we can always make another video and kind of add on to it and saying, okay, here's our tutorial. Somebody requested that we add this feature. Now we're going to show how to add that feature. Function library, it's incredibly lucky, 5 a.m. fine. Thank you kindly. No problem. Yeah, if you have any questions about the function library and how it works, just let me know. Or if you want to see me do something specific with it, let me know too. A good rule of thumb is that we can make categories. So if we come up here, we can type in score, and we can now categorize anything to do with score into that score category. So this is always very useful for organization. These are more like utility. You can put those in the utility section, and that makes it easier to organize those. Got here late. Would you be able to quickly go over how you can call those functions from other blueprints? So innately, when you have a function in your function library, you can call them from other blueprints. So let's make a new function, and let's call this test function call. And we'll make an input of a Boolean and an output of a Boolean too, just so you can kind of see that. And in any blueprint that we have, so let's go to this coin blueprint. Here's our event graph, and we can simply call test function call with our input and our output. That's cool, but don't you think it's a bad practice to keep hard references in the function library since it's global and always loaded? Yes and no, Andre. Also welcome. So in our case, we know that our game instances is always going to be loaded. It's always there. So a hard call to it is not bad practice. But you might want to be careful of hard references in other scenarios. How efficient? It is very efficient, but yeah, you do want to be careful about using hard references in scenarios where you might have that continual propagation of information. But in this case, it is okay for us to use it because the game instance, the game mode, they're always going to be there in our game. The player's character is always going to be loaded. So in those cases, it is not inefficient to do so that way. But you do want to avoid if the coin references, I don't know, like a table, and then that table has a hard reference to, a chair, and a chair has a hard reference to a planet, but you go into a shack with only a chair, now that chair is going to have to load the coin, the table, and the planet itself too. So you just want to avoid those cascading references, but having a few hard references is 100% okay. And in some cases, using soft objects, I believe, I could be wrong on this, I believe can load things into RAM and is a popular source of RAM issues and a high RAM usage in games in Unreal. So there are negatives to using alternatives to the hard reference casts. Any other questions? Any other things that you would like to see? I know, Serene, you wanted to see the coins move. We could show that off if we want to. So if you're watching on YouTube, by the way, the general aspect of the tutorial is done, but we can do some, user requested things now from our Twitch chat. And if anybody wants to see something added from YouTube, just add it into the comments, ask me questions about things, and then I can showcase those in separate videos that we can tie to in like a playlist for this. So let's make these coins move. Let's do that. That sounds fun. We are going to be using what's called a timeline to control the movement of these coins, maybe up and down and spinning or something. Now the nice thing is we connected the collision box to the coin mesh itself. So if we move the coin, the box with which you can interact with it gets moved with it, which makes sense from a player perspective. You would expect to run into the coin to be able to collect it. So let's come over here to the event graph and let's make a timeline. And we're going to call this coin movement timeline. So what this does is we can play it and we can run something every time this updates. So let's double click on this and let's add a float track to here. And very similar to like making keyframe animations in, any sort of like video editor or any other art tool, this is also what we're going to be doing, is adding keys and values that this will transition from while this is being updated, right? So we move from left to right and we can add keys to this curve. First one being 0, 0, and let's add one for 5 and 1 because this is a 5-second track. We can also just make this 1 second and have it loop. It doesn't really matter. We're going to be doing a lerp here anyway. So let's actually just set this to 1 and we'll set this key to 1, 1. It is a linear track here to here and it will loop. So it will be very linear along that. We could also make this a bit nicer by making it a float interp, so it goes faster near the center and slows down near the tops and bottoms for that. So as the coin bobs up and down, it slows as it reaches that those peaks, that the azimuth. I don't even know if that's the right word to use here, but the tops and the bottoms of the peak. I don't know if azimuth and zenith are the correct terms here. Okay. Let's rename this track as well to something a bit nicer. Coin bobbing. And on event begin play, we want to run this. So we can play it. And we can set this to loop here, up here, loop. And every time this updates, which will be every tick, we can grab the coin mesh and we can set the relative location, lerping vector, and let's say minus 50 to 50. That might be a bit too much. Let's see how that looks. So what a lerp does is it moves between one point and another based on a value between 0 and 1. So like the percentage of the way that it should be through that. So by setting up a timeline that goes between 0 and 1, we have the exact values that we need for that lerp. And as that timeline plays, it's going to move between -50 relative to its starting location and 50 on the z-axis, which is the up and down. So this should bob the coins up and down over time, unless I made a mistake, but we'll see. As you can see here, it is not reversing. It is moving up, it is not reversing. So we can fix that. That was my mistake. We need to make this, let's make this 2 seconds in length. Add another key, set this to 2 and to 0, so that it actually properly waves up and down. That was my mistake there. Now the proper locations for this are not the greatest. They are bobbing up and down, but they are going through the ground a bit, which is not super wonderful. We could fix that. Or you can direct reverse, show both ways for the YouTube dudes. I could. I don't know if that's the proper way to do it though. Because we'd have to have an event that fires when you finish that to reverse it. In this specific case, I think that reversing it would not be correct. And probably be more work than it is to set up than just looping and having the reverse handled in the timeline itself. But yes, you could do that. So once you finish, you could call on finish to reverse the coin movement. And then once it's reversed, you could then play it again from start. It would be a little bit awkward to do here though, and I think would be more confusing than anything. I think that it would look confusing for coin movement. I don't know if you agree with me on that though. I'm gonna skip that for now. I will. Let's see here. Oh, I like that. That's much nicer. It is still bobbing too low though. So let's get that fixed. We need to add in the default height of this here, which is about 100 units off the ground. So let's make sure we put that in here and do 100 to 150. Yeah, but the thing with the movement is I'd have to store the state of whether or not we are in the upward movement or the downward movement, and then do like a branch here. It's just in this case, I think that showing a reverse movement, in this specific case of coin bobbing, reverse is kind of bad. And I think would be more confusing to teach and to try to make sense of. Could do a flip-flop. Okay, I could do a flip-flop. It's going to look a little bit awkward. But let's say we have here our floating coins, right? Between that default movement and let's say -80 to 130. Oop, sorry, that was bad. 80 to 130, sorry about that. No, I can do it. Just give me 1 sec, because I want to show what, you know, this is the intended output, right, is these floating coins. And we can still run into them, we can still collect them, the exact same functionality is there. As you can see. The alternative solution to this, as Bless3D mentions, is that there is a way to handle the movement in a different capacity. It is it's really awkward though. All right, we'll use the flip-flop. I wouldn't recommend this in this case, but there are use cases where you might want to reverse the movement, right? Like a door opening is a great example, where you would use a timeline for a door to open it and then reverse the timeline to close the door, right? Make more toots in the future? Yeah. I mean, actually, if we want to show off reverse movement, why don't we make a door? Why don't we just make a door? Because I think that that's a much better use case scenario to reverse timeline movement than the coin bobbing. We can also make this coin rotate, so we can actually do another set relative rotation. And we probably have a lerp on a rotator too, so we can use the exact same thing here. To lerp between which axis are we moving on? Oops, sorry. Hiccups. We are moving along the green axis, so the pitch. I am getting that correct. So between 0 and 360. It's probably going to spin very fast. That is the that is the wrong one. Hold on. It's the wrong one. Why is that one wrong? Oh, it's the Z. It is the Z. I'm dumb. What's not? Ugh. Why do you do this to me? Wait, did I have it right? Wait a second. Oh, I know why. Hold on. There's one thing I need to do. Z was right. I thought Z was right. I know why. It's because we rotated the coin. The base mesh of the coin is rotated. I was setting the relative rotation, not the world rotation. And because of that, this rotation is actually correct. This is what we get for rotating the base mesh, by the way. I will talk about all my opinions on games. I played Avowed for like 20 hours over the weekend too. I'll talk about that after the tutorial stuff. It's because we rotated this. So the default of this coin is like this. I'm going to fix that actually just by making it a bit easier on myself. I'm going to make a coin mesh. I'm going to take a cylinder. I'm going to make it look like a coin, so that we can work with the right dimensions here. I think that looks about right. And I think I can save that to a... Let me go over to let's go to the modeling section. Oh, I can just make it from the modeling section. This is pretty new to Unreal, is this modeling. You can actually model in Unreal itself. Let's make a cylinder. Oh. These are the these are exactly Bitcoins, yeah. You got it. Modify the height. The radius. Okay, I think that's a little bit too big. Close though. That's about better. A little bit thinner. Okay. And did that save that somewhere? Here it is. Let's move this over into our content. New folder called meshes. Something not the only one getting that visceral total confusion when something unhinged and unexpected happens. Hey, I'll tell you what, you can work in game dev for decades and decades and still get super confused by the stupidest things. Okay, let's edit the pivot. And is my coin now standing up? No, it's not. I need my coin standing up. I am still quite new to the editing tools, to be fair. Oop. Go. Okay. Let's change this from a coin, from the cylinder to the coin. Rename this SM underscore coin. And we'll give it the default there. And let's change this to coin. And then reset the rotation. Oh. Oh, that's... Oh, yeah. Go. Reset the scale. Okay, here we go. Now we have our own proper mesh with the right things. And then modifying the Z value of the movement there should be proper. Although I don't like the way it moves, but we can always get that fixed up. Pivots matter. There's the lesson for the tutorial. Pivots matter. All right, let's see here. The reason being is because it's spinning, doing a full 360, and then going from 360 back to 0. So I will make a separate track that is just the linear 0 to 1 over the 2 seconds. And we're going to call this coin rot. And I think that should be, yeah. Okay, and then we can remove that coin collision box hidden in game so that we can see a bit better. So that looks a lot better. Falconian, thank you for the follow. And I hope you are all having a great Monday. So that looks a bit better. Okay, let's make a door. Doors are always that one thing that everybody seems to have struggles with when it comes to games. I will show you a very, very simple way to make doors. Let's make a new blueprint, and we will call this BP door. I don't really have a place to put this door. So let me modify things a bit so that we have a location for it. Yeah. We will put the door in between there. Hey Kent, we're doing a tutorial today. But is there a simple way to make a door close when you look away from it? Like, do you want it to open when you look at it? There's definitely a way to do it. A pretty simple way too. But tell me exactly what you're wanting, and we can actually implement it here if you want. Let me think here. I could teach you guys a better way. Or the simplest way. I want to make a... Door is opened and you turn away, it no longer appears in camera. Yes. So I want to make an interaction system. Ooh, these are a bit more complex, but we could do it. We could do it. I could make an interaction system. Let's do it. Let's just do it. If you're gonna have doors, you might as well have an interaction system for it. All right, let's start here then with, where is my event tick? So we're gonna be using a line trace on every tick to determine if the player is looking at something that they can interact with. And if they are, they can interact with it. So let's do a line trace by channel. This is going to be the visibility trace, starting from the first person camera. Get actor, or get, we can just do get location, get world location. And ending with the world location, get the forward, get forward vector times, let's say 300. We'll draw persistent for the moment. No, we'll do duration. Is that correct? Getting from 0, 0. It's either multiply or it's add, and I think it might be add. I'm pretty sure it is definitely add. Not multiply. Okay. It's a little hard to see, but as we look in front of us, we are doing a line trace to the world. The boxes are where we're hitting. It's a very short line trace. Right to about here. And this will be able to determine if we can actually interact with the thing that we're looking at. That's a start. Let me think. Let's make a blueprint interface. So we didn't cover this in the main tutorial, but we'll cover it here. Let's make a new folder in here called interfaces. Blueprint interface, BPI, interact. So we can use this to determine if the thing that we're looking at and hitting with that line trace is something that we can interact with by giving the actors in our scene, the blueprint actors, this interface. I just want to get an informative opinion, but wouldn't it be easier to add a box or sphere collision to the camera so you can only have to deal with overlap events? I always wondered why I see people use line traces on tick instead. Seems pretty intense. One line trace on a tick is pretty cheap to do. There are more expensive traces, but a single line trace is really, really cheap to do. The reason why you might not want to deal with overlap events is because a line trace is based on visibility. So whereas a box or something could go through a wall, a line trace can stop on the things that it hits. So you cannot interact with something that is maybe behind this wall. So a line trace is way safer to do. Hey Falconian, new here, how often do you stream? Every day. Fantastic to watch how your brain works and problem solves. Well, thank you, I appreciate that. I don't think I'm a very good teacher, but I'm trying to get better, and forcing myself to do these tutorials puts me in that scenario. But we stream every day from 9 a.m. Central European time to about 4 p.m. Central European time. Our stream calendar can be gotten with ! schedule, and you can see what we're doing and planning to do every day of the month. Weekends I mostly have off. I don't want to burn myself out. Rank 2, thank you for the subscription. That's really kind of you. Thank you so much. I don't know why that isn't appearing. It will appear. Hold on. A little bit slow sometimes with that. Yeah, if by the way, if there's anything that I do and I'm not explaining it very well, just let me know. I can explain it a bit differently. So with like the line trace, for instance, it's, you know, we need to determine where we're drawing the line. So in this case, we're drawing it from the start location of the player's camera. So right in the center of the screen, right? And we're drawing that to we're getting a forward vector from where the player is looking and drawing it 300 units in front of that initial line based on the player's, where the player is looking. And we can increase that to increase the distance at which that line trace is done. And then from this hit, from whatever we hit, we can break that result. We can grab the other actor and determine if that actor does implement interface with interact. So let's try this for now. Let's print a string. Just hello if the object that we're hitting implements the interface of BPI interact. Now right now, nothing in our scene implements that interface, so you won't see any debug output spitting out hello, right? But if we have our BP door, and let's just add a cube for now so we have something physical to hit. If we go up into class settings, we can add an interface here. And we're going to add our BPI interact. And this is a very cheap way to communicate with blueprints because there are no hard references, right? So rather than checking, is the actor that I'm hitting a door? If so, let's run code. We can simply call this interface and say, okay, it's something that I can interact with. So tell me, so I'm going to send a message to that door to interact with it. But it's a very light exchange of information here, and I don't have to do any hard references. So let's throw down this door. And you can see if we're looking at a coin, no hellos. If we look at the cube though, we're printing out hello. This is something that we can interact with. So how do we actually get that to occur? Let's go to our interface. Execution, thank you for the follow as well. Now, very similar to the function library, you can see that we can add, oh, it's a chaos spot, never mind. We can add a function to this BPI, but we can't edit the function. What you can think of a BPI as an interface is a messaging system. You know, you've got mail, right? You have a new unread message, but we're not going to be able to put any functionality into that. This is just a, hey, hello there, Mr. Blueprint, can you do something? And in this case, we want to send a interact message to it. So we can say that with BP door, this is an interactable, right? We have this interface. We can now see that the interface over here has added this interact function into our blueprint. And we can double click and we can call that. This is a little message. This little symbol indicates that it comes from a blueprint interface. So on event interact, we can, let's just, for right now, let's just destroy the door. Let's go back into our main tutorial section. Let's make some inputs here. And let's make a input mapping context, IMC main. So this is like a, think of input mapping context as what you are contextually doing in the game. Are you fishing in the game? Are you on horseback? You might have different input contexts for those different scenarios. Our game, you just run around and you do things, right? So we can just kind of shove our inputs into this main context. And let's make a new input action called interact. So let's do IA interact. And we don't need to touch this at all. Back in input mapping context, we can add a mapping. And let's say IA interact. And now we have the option to select keys for this. So we're going to click this and press E. And this is the E on our keyboard. But of course, you can set multiple. You can select as many as you want. Maybe you have like controller support too. So you can tie controller and keyboard inputs to the same action. So that if the player is playing on keyboard or mouse and keyboard, or controller and mouse and keyboard, they fire the exact same actions in your blueprints. So in this case, let's just make it E. E for interact. And let's put these into a new folder called input. At the start of the game, let's make sure that the player has these input actions available to them. So we'll go into the level blueprint and we're going to grab the enhanced input local player subsystem. Yes, it's confusing. And yes, like everything else with blueprinting, most of your ability to blueprint is going to be whether or not you remember what to do. There's probably ways to do the things that you want to do in a game, but if you don't know what nodes to type, you won't know how to do it. So if you're wondering how I know it so well, it's just because of practice. And that's really what it comes down to. Practice makes perfect in Unreal blueprinting. So that requires a player controller input, as you can see here. So we need to say, okay, the player controller, grab their enhanced input local player subsystem. So basically, what mapping context do they have available to them? And we want to make sure that we add mapping context. IMC main is our new one. So now the player has the ability to interact. They can press E, but nothing is going to happen when they press E because we don't know what should happen. So let's come over to the first person character and we can now type in interact. And we have this enhanced action events. Input action IA interact. Let's move this print down to here. And let's do started. So when the player starts using this action, we print the string hello. So when I press E, we can see every time I'm pressing it, we are adding hello to the screen. So we know that the action is working. What we want to do is make sure that if we hit an object that the player can interact with, and we interact with it while we're looking at it, then we need to send the message to interact with it, right? So on this line trace, if the object implements the interface of BPI interact, let's store as a variable the hit actor. And if what we're looking at does not implement that, or is invalid, and actually we can do that check here. So let's do an or boolean. And let's type in a validity check. or is not valid, sorry. So we have to reverse this Boolean. You know what? Let's make it a bit simpler. Let's just do another branch. Branches are cheap. Branches are quick. And I want to have those separated just out of safety. So first we check, does the actor implement the interface? If yes, good. We have hit an actor that is valid to interact with. Otherwise, does the actor implement, or is the actor even valid? You know what? Let me back up even further. Let's make this even simpler. Let's make sure that it is valid when we are interacting with it, and if not, if either of those are false, we will just reset the hit actor to nothing, to empty. Thanks for doing these tutorials. Well, I'm very happy that you guys are watching, and I hope you're enjoying it. Unlike YouTube tutorials, I think that watching on Twitch is a bit nicer because you can ask those questions, get those clarifications. Okay, so if we hit an actor that is valid and implements the right interface, we set it as a variable. If it is not either of those things, we reset it. Now back down here in the interact, we can just grab the hit actor and determine if it's valid, again, out of safety. It is not like pending garbage deletion or something. And if it is valid, we can send the message to interact with it. Now, if this message, if the object that we're hitting and interacting with does not implement the interface, this just doesn't go anywhere. It's like, hey, are you interactable? Can you interact? Oh, you're not? Okay, so whatever then. There won't be any error. It won't really cost anything. And this is out of an abundance of safety. So, you know, for normal things that we hit like this, we compress E, nothing happens. Nothing. But if we have something that is interactable and we're looking at it, we can interact with it now. And we can fire that event, which in this case destroys the interactable. And we can set that to be anything on the children, right? So because BP door on interact is set to destroy, we can tell maybe the coins can be collected when you interact with them. So for instance, if we wanted to, for any instance, we could add the interface of interact here. And on interact, we can actually just run the same functionality here. So we could interact and pick up coins by pressing E on them. Maybe we want that, I don't know. We have it now, and it was as simple as just adding in that interface and telling it what to do. So interfaces are very, very powerful. They're very easy to set up, and they are very scalable, right? And we can add, maybe we want something to appear when the player... You know what? I'll give an example. If you guys can give me 1 second to load up my own game, I can show you what happens in very similar functionality. We'll let that load in the background. Because I also use interact there to show tooltips of like what the player is looking at. And you know, we have to hide those tooltips when the player isn't looking at those things. Okay, so let's make this door. We have our door here. Let's move it into the proper setting. This is a replacement for older or different tutorials that might show you like, okay, place a couple of boxes down. And when the player is within the box, enable input on the actor, and then the player can interact with the actor directly. Making a generic interaction system, I think it is a bit more complex, but it's also much quicker to scale out to the rest of the game world, because all you need to do is add that blueprint interface in and tell it what to do when you interact with it. It's way, way better, I think, from a logic point of view and from a larger game point of view. And you don't have to add a whole bunch of boxes around your world that determine when the player can and cannot interact with that object. And then you have to ask yourself, well, what happens when the player is interacting, is overlapping with multiple objects? The nice thing about the line trace is that the player can only hit one object at a time. So the player can only interact with one thing at a time. And you don't have overlapping actors potentially causing logic issues. It is one thing at a time. Okay, BP door on interact. Let's set up a timeline here. And this will be door open, or door open close, let's just call it. And let's add a variable here for whether or not the door is open. B is open. Now the reason I put a lowercase b in front of my booleans is that it is kind of proper coding practice. And when you use them in blueprints, the b is invisible. So kind of a sneaky little expert functionality there that your coders will love if you do. So based on whether or not the door is open, we either want to play the timeline to open the door or to close the door. So play or reverse. And that is as simple as, if it's open, reverse it. And if it's closed, play it. It's a little backwards. You could always make this B is closed. In fact, I'll just do that. B is closed, so that the true and falses are not kind of hard to see there. Now let's make this look more like a door, shall we? Doesn't have to be perfect, just has to be something. Okay. Make it a little bit wider for here. Perfect. Now the problem is if we open this door right now, it's going to be based off of this root right here. So if we rotate the door, you can see the issue. Doors do not normally rotate from the very centers of their beings. We can instead use what's called a scene root, which is a invisible point in your object that you can move around, and you can use it in mathematical calculations. You can add objects to it, and it is separate from the rest of your meshes here if you want it to be. So what we're going to do is set the root right here in the center, and then the cube is going to be placed right here. So that now, and we're going to make this a child of the scene root too, when we want to rotate the scene root, it rotates the door more correctly. And we don't have to worry about the pivot of the door mesh itself. Now it should just open more or less like you would expect the door to open up. Oh, what did I just do? Don't do that. I don't know what I clicked for that. Okay, let's go over to the door open close timeline. Let's open this up. Well, let's add in a float track again. Again, we're going to do the lerping. So I think this is just much better. 0, 0, and let's make this... Let's try 1 second in length. It'll be pretty fast. And a new key up here, 1, 1. And I'll set those to be not linear, so it's a bit nicer when it opens and closes. Oop, let's rename that too as well to door track. So let's call a lerp. And we will do a lerp on the rotator for the scene root. So let's call set relative rotation. I think we want to do. Any other variable naming best practices beyond just bools? That's a really good question. Yes, 2. I can think of 2, and there might be more. And I would ask a better programmer for a more accurate information. Number 1, it's better that your variable be accurate than short. If you can be accurate and short, great. If you cannot be short, it is better to be accurate. Nobody wants a variable named A or float, because it just, okay, but what is it doing? What is this float doing? What is this integer doing? Don't name your integer integer. Please name it something that will make me understand, oh, this sets this information or this controls this information. And number two, especially for Booleans, your Booleans should be answerable with true or false. What that means is, if I have B is closed, true should mean that it is closed, and false should mean that it is open, right? I shouldn't have a, what's a good example of a confusing Boolean? Here's a good example. B is not true. Great, let me test if this is not true. Wait, is true? Wait, true would mean false, and false would mean, you know, it's like, don't make your Booleans confusing. Make them very simple to understand. B is closed, or B is door closed. Yes or no. Those are two that I can think of off the top of my head. All right, let's do another lerp on the rotator. And this is going to be along which axis? The z-axis, the yaw, from 0, let's do 0 to negative 90. You don't need f floats or f strings. I just wouldn't name the variable f float or f string, is what I mean. Like, I would just, if you're naming your variable, name it something that is understandable, even if it is lengthy. So maybe your variable is, you know, offset between actor and, you know, current actor and hit actor. It's long. Oh, if you float is health and f health, you know what? Let's test it. I've never done that before. Let's try f health and see if it automatically hides the lowercase f. It does not. It does not. I know for Booleans it works with the lowercase b. I do not know if it works anywhere else. There's a lot of little hidden functionality in Unreal there with blueprints, and I only know of this one. But it was good to check. Okay, relative location. Let's see here. Going back over my bools now. I mean, you can just, you don't have to do it with the lowercase b. It's not like it changes anything in the functionality. I don't know when and why I started to do it. I'm actually going to be honest. I don't know when and why I started to do it. But I just do it off of principle. You know when? Do you, Bartosz? You don't know. Should we check? Let's see if ChatGPT knows. Why is it good practice in Unreal to name a Boolean with a lowercase b in front of it? Does it help programmers or debugging in any way? It probably just is a convention that is pulled from. The B prefix tells anyone that it is a Boolean. Or, I mean, yeah, that's true. It does help with that. Hungarian notation, which prefixes indicate variable types. Yeah, but B is invisible in Unreal. The others are not. Avoiding confusion with functions. Well, that's true too. Yeah, avoiding confusion with functions is always good. 100%. Like with functions have their own naming schemes too. With functions that you would normally want to do capital letters. And usually for variables, you would do lowercase. I mean, it probably is just from C++, like you say, Andre. I think you're very, very, very correct on that. Okay, what were we doing? Set relative rotation, but we need to cache the rotation initially. The relative rotation. We can do that. Let's do that real quick. Let's cache the rotation. Cached door rotation. This way, no matter which direction, however we rotate this in the scene, we can rotate it correctly from that initial starting location. And that'll be based on the scene root. Get location. Oops, should be rotation. Sorry, it should be rotator. Get rotation. Instead, I will set world rotation or the default scene root. I'm sorry, not the scene root. This scene root, please. Equal to the cached rotation, and then the cached rotation plus. Why can I not add rotators? Combine rotators. Thank you. That's so consistent. I think it's -90, isn't it? Or no, it should be 90. Based on that alpha. Is that correct? Should be -90. Okay, let's see if this works. It is not interacting. Play, reverse. This combine might be messed up. I'm just going to use a... I'm just going to do a regular lerp float. I don't know why it's messing up. Let me debug it. That's weird. I think it's this combination that's messing up. Okay, let's do it this way. Split the struct pin. We only want to change the yaw anyway, so let's do a lerp. And we will lerp between the yaw, cache to rotation, so yaw, alpha, and the yaw plus -90. Also subtract 90, but we'll just do it this way. That is fine. Okay, check it out. It is not moving at all. Because of collision? Could be. One second. Should be pretty fast. Let's print this. Causing a bug on stream with tutorial is actually probably pretty good because then we can show off debugging. We'll not print that to log. Just show me what values we're putting in here. I'll take it from there. I know why. I know why. Is closed. I don't know why. It should be. It should open it. It won't close it, but it should open it. That's awkward. B is closed. False. Oh, I know why. They do have to be reversed like this. I'm sorry. My mistake. There we go. And in order to open it, on finished, we need to set closed equal to the opposite. So we just take the opposite of that. Move this down a little bit. So now what's set to closed is true. Oh, I know why I did that. I was actually right. I just, by default, the door should be closed. In which case, if it is closed, play it from the start to open it. False. I messed up. And therefore, it should now be openable and closable based on that. Pretty easy door. Pretty easy door. I can turn off that debug for the line trace too. If you want to get it even crazier, I can show you kind of what I did with our game that we're working on. Turn off some of the sounds here. So like when we look at things in our game, you can see a tooltip when you look at them to see what they are. We have different tooltips for different things. So like our door here, we can see that it is in fact a door. We could add a tooltip if you guys want to see how to add a basic tooltip for displaying that information for the player when you look at something like that. That is quite useful. Let's see here. Let me think for a brief second. Yeah. Yeah, we can do it that way. Okay. Let's go to and make a new UI widget. Let's call this, not a widget preview. WBP hover tooltip. Let's make a new canvas panel here. Although we don't really need to for this. In fact, I won't for this one. I'm going to add in a border. We can make it very similar to the one that you saw in my game there. I'm going to wrap this with a size box. This will allow us to override the width and height of this. Actually, we'll do a minimum desired width of 200 and a height override here. Make the border black and a bit transparent. And we'll throw text inside of there. We can center this text. Let's rename this to T tooltip text. Make it a variable. make it look like that. This way, because we do override the height, so the height is set in stone, but the width should be a minimum. So if there's only one thing in there, it'll be minimum like that. But if there's more than that, it should scale up like that. What we could do is we could also set this to be a minimum desired height of 50. And then wrap the text at, let's say, I don't know what a good amount is. I can try like 150 maybe. 250. So if it's a bit too long, we can wrap the text to the next line. But default, it'll look like that. Okay. WPP hover tooltip. Let's make this a function update tooltip. We're going to bring in a string for new tooltip text. And this will be simple. Get tooltip text, set text. Convert the string to a text. Add a return node. And by default, we want this to be invisible. So we'll come back here, and on the core details of this, we will set it to collapsed. Normally you would put this on a main game HUD. We're not going to put this on a main game HUD this time, but it would be proper practice too. We're just going to add it to the viewport. You know what? Let's make a main game HUD. Why not? Why not? I'll show you what it looks like. WBP main game HUD. And what we're going to do is add the canvas panel. We're going to add our score. And size to content. Anchor. Fix the offsets, and that'll look kind of like what we have now. And then we can add the tooltip to the canvas panel too. And we're going to put this right where it belongs, in the center of the screen. Oop, that's not the right one. Centered there, and then we can offset this to about here. Let's try 180. And instead of adding the score widget to the viewport, we will instead add the main game HUD. And it should work exactly like before, nothing too crazy, because when we update the score, we're calling the main game HUD, and we're not checking for top level. So on the top level is the main game HUD. Below that in the hierarchy is the score widget, but because we're checking for any score widget, we still find that one and return it. I believe, if we were searching just on the top level, it would not retrieve it. But that's fine. Now what we can do is we can make some functions for telling the hover widget when to display and when not to. So let's go into our BPI, and we will do interactable. Is it table? Interactable table? Hey Janko, how you doing, man? What's the spelling of that? It is a interactable hovered, and we can do one for interactable stop hovered. Back in our first person character, we can actually run a call to the hit actor for hovered. And when we stop hovering it, we can also get that. So before we set hit actor to, actually have to put a little bit of a check here. We need to do, is actor valid? If false, we will want to hide the tooltip completely. Otherwise, we want to call the hit actor, stop hovered, and then set that to be gone. Jump back to our function library so we can actually tell this widget to appear and when to disappear. Okay, function, show tooltip. We will simply get all widgets of class. Again, we know that there's only going to be one tooltip in there anyway, and it's always going to be present. So let's grab it, update tooltip. And we will have an input of a string. This will be tooltip text. I'm feeling pissed. Don't worry, well, let me know about that after our tutorial section here. So show tooltip will set this to update tooltip, and then we need to tell it to be visible. So let's set this to set visibility, and this will be not hit testable, self and all children, as we don't want the tooltip to be clickable or to eat input. So we want not hit testable. And then we can make one for hide tooltip. Now in this case, we don't need to update the tooltip. We just need to tell the tooltip to go back to being collapsed. And we can put this in a new category called widget. Or even tooltip if we wanted, but widget works fine too. So now on the door, we have these interface calls now. We can go interactable hovered, stop hovered. We can go hide tooltip and show tooltip. And for the tooltip text, we can just simply type in door. We will hard code that a bit. But like before, you could drag this off and make a instance editable variable to have different things. So maybe we want, here's a good example. Let's go back to our coins. And let's add a new variable here for a string. This will be coin tooltip text. We can go into DT coin now, and we can change this to be bronze coin, silver coin, gold coin, oops, iridium coin, super coin. And then back in BB coin, we can also add these calls. Hide tooltip. And on hovered, we can show tooltip. But now for the text, we can actually just grab the data table row and tell it to use the coin tooltip text. You can hide unconnected pins too, is a little nice little feature of that. So let's see if this works, or if I missed something. Silver coin. We have one issue that we can fix, which is that the tooltip is not properly getting destroyed when the player is not looking at that thing. Although we are updating it properly. Let's fix that. That is a very important aspect to it. With the line trace on hit false is valid. Yep, that's because I remembered I wanted to add the hide tooltip here before we hide the actor. That was my fault. So now if you're looking at the coin, you can see the coin and the tooltip, and if you don't look at them, we do not see the tooltip itself. So this is doubling our interaction system with our tooltip system as well. Nice and simple. So, is there anything else that you guys would like to see? Good beginner programming project is an AES descriptor? Oh my god. These VODs go up anyway? Yes, they go up on our YouTube channel. So if you type in !YouTube, you can see not only all of our previous days of game development, but you will be able to see this VOD once we put it up online. Can you turn it into an MMO? Yeah, let me just... Here's what you do if you want to make your game an MMO, guys. Okay? So, let's go to the game mode. And we're going to go into our game mode. Let's add a variable here for B is MMO. Now, by default, your game is not an MMO. You just select this boolean, compile, press play, and now your game is an MMO. Hope that helped. Not true. I know, I think gamers wish that it was that easy, but oh boy, is it not. All right, if there's anything else, say it now. I will quickly run to the bathroom. So if you're watching on YouTube, sorry, but I have to go to the bathroom. And if there's anything else here, let me know. If not, in the YouTube comments, you can add things or feedback or info or questions. I will answer them, and we can make separate videos for doing those things too. So give me 1 second. I'll be right back. And put any questions you have or things you would like to see in chat. Here. Okay, if there are no additional things that we want to do in chat, don't worry. If you think of something later, we can jump to those too. But for now, I will consider the tutorial itself complete, and we will upload this on YouTube right after the stream ends today. And if you're watching on Twitch, stick around because we're going to be jumping over to our own game to develop that further. And yeah, if you're watching on YouTube, thank you for watching this. I know it was very long. It was like 4 hours, but I hope that this has helped. And like I said, if you have any questions of things you want to see, we will make new videos and we can add those on. I cannot do everything in the engine, clearly, but you know, a lot of this basic stuff is very easy for me to show off, and I've done it enough times before that it's not too much work for me. So yeah, if you're watching YouTube, thank you for that, and I will catch you guys on the next one. Take care, guys. Bye-bye, YouTube.